Well, I missed them. I had more than I spent half my time behind it, but I missed them all the time. I must have been just a little bit early. Go ahead.
Very good.
And I can pull you over. You got 35.
That would be an easy question. I know
Good afternoon, everyone. I'd like to get started. Welcome you to the Management Committee meeting. I'm Earl Shepard, the chair for the committee. I have Mr. Lewis Walters on my side, who's the co-chair, Ms. Jenny Jones, co-chair, Mr. Cleveland Lattimore, and Ms. Erlene Ennis. She may be on her way. I'd like to thank everybody again for showing up to the meeting. We encourage you to be eventful and be respectful at all times. We do have people that are online with us, and we'll be responding with them also. Everything is being recorded, so be very careful, again, about what you say and how you say it. We need to stay on topic, so we ask that we allow everybody to do their respective jobs and adhere to each other in that manner. Anyone wishing to ask questions, we ask that you refrain from doing so until the presentations are over with and come to the podium and you are able to speak at your public comment section time. We have one Waste Management Committee recommendation open. It's 312, the liquid waste treatment maximization. We will talk about that. And we have a pending recommendation, improving public communication and understanding of liquid waste program and revisions of the liquid waste system plan. So we will discuss that also. We now have a couple of presentations, Glassway Storage Project Defense Waste Processing Facility by Steve Maxwell of BOESR. And at 5:05, crawling along, the waste tank sampling technology demonstration by Jolene Sykes, BOESR, and Greg Oct, SR. So again, please hold all comments and questions until the presentations are over with, and at that time you can go to the podium when it is time for your public section, and we will answer the questions accordingly. Jim, glad to see you. So, if we have Steve Maxwell, you may come up and do your thing.
Thank you.
Thank you.
I'm Steve Maxwell, Federal Project Director for Glassway Storage Project. I want to recognize the board for your gracious invitation to discuss the Glassway Storage Project with you. Also, I'd like to recognize Jessalyn for all your family support, getting this thing ready to rock and roll. So, why am I here? I'm here because you guys invited me here. It's a work plan requirement. So I graciously accepted. I'm going to describe the Glassway Storage Project, which is a line item, and it is not another Glassway storage building. Okay, there's two reasons why we're not building another Glassway storage building. Number one was the upfront cost, which I'll talk about later. And number two is we don't want a great big nuclear waste facility that we have to DOT in the future. So what our challenge was is how can we store these canisters in a safe manner, be flexible with the canister production, with the rising and falling of the federal budget, and be able to support the liquid waste plan till we're done producing canisters. Okay, first, since we're DOE, I've got to go over all these acronyms. The first part is, comes right out of the DOE 413-3B project management for capital asset projects. These are the different stages that we have to go through to get a line item recognized, authorized, funded, concurred upon, and just depending on, you know, how involved the project is, some of these things can take years. So CD0 is, you got a gap in your capabilities or your infrastructure or something, and so you have identified a mission need. So you brainstorm and say, how can we fill this gap in our mission need? You come up with a guess, and then you weed it down, and you come up with a good presentation that you have to convince the acquisition executive that this is the way to go. That's CD0. CD1 is when you start putting all these good ideas together. You have a very conceptual, high-level design with rough order of magnitude cost, and it kind of gives the senior leaders in headquarters kind of a ballpark of what you're thinking about and kind of how much this is going to cost and how long is it going to take, and is it going to meet your mission needs. Okay, so once you get the CD1 approved, then you start doing the design, you start doing the schedule, and you approve the performance baseline. That's it. You're going to build this by this, and it's going to cost this much. You've got to go through all these checks and balances. Once you get the design, you start construction. Like the Glassway storage project, it's probably going to take us 3 years to build it. A lot of concrete. CD4 is when you go from construction and you turn it over to ops. Now you're going to test it, make sure everything is functional, make sure you got all the procedures, make sure everything is all lined up, because when you turn it over to operations, they want something that's going to run properly and going to operate properly and they're going to finish and fulfill the mission need. Okay, ALARA. What's so important about ALARA with DWPF canisters? A lot of radioactivity in them, so we need to keep them shielded. And so as low as reasonably achievable, ALARA is a big part of this project. Balance of plant. What is balance of plant? That's all, you know, you build a concrete, it's like building a garage. You'll see this, it's kind of a high-tech garage. You got the concrete, now you got to put in all the electronics, control panel, the TV cameras, balance of plant. CDR, Conceptual Design Report, that is built so you can get a CD1 approval. That is the high-level design, the high-level rough order magnitude cost, and the schedule. Canisters transfer station, that's our concept. We're going to build this 2-story concrete garage where the shielded canister transporter, which we have on site, is going to pull up. It looks kind of like a Jiffy Lube in a covered building, a garage, and there's going to be 3 holes in the floor with shielding plates. We're going to move the shielding plate. The SCT is going to put a canister down into a great big concrete storage. Actually, we're calling it a container. Defense Waste Processing Facility, that's the home of vitrification for DOE. Glassway storage building, that's the name of this. That's the name of what we're not going to build in this project. We've got 2 of those over there. There's about 715 canisters, storage positions remaining in glass waste building number 2. Glass waste building number 1 is full. Headquarters, we all know what headquarters is. Request for proposals. When we want to build this thing, we'll go out, expressions of interest or comments business daily, or somehow put a request for proposals. Hey, bring your proposals. How would you build this? How much is it going to cost? What's the schedule? Alternative study. How did we get to glass waste storage project and away from the glass waste storage building? Well, Savannah River said, we're going to build glass waste building number 3. And headquarters says, no, you're not. Too expensive. You got D&D, find another way. So we got subject matter experts. We looked all around the complex, see how everybody, West Valley, Hansford, Idaho, is storing all their radioactive waste. We went to the spent fuel industry, because they're already storing their spent fuel because Yucca Mountain didn't get opened. And so now everybody's going to above ground dry cask storage of all the spent fuel. So we got all these ideas. We ended up with 18 or 19 ideas. We started brainstorming. We developed a grading criteria. We weighted them. What's most important? Safety and alarm, cost, construction, the technical approach, the operability, life cycle cost. We all weighed those things, balanced them out, graded them out, and the Glassway storage project came out as number one. Optimization study, that's what we're in the middle of right now. Since we developed the canister interim storage project in this alternative study, which is the Glassway storage project, we sent that up to headquarters and said, hey, this is what we're going to do for storage at Savannah River. And headquarters says, that's very good. Now, what are you going to do about transportation? Because this is a storage facility. We're going to put them in these great big concrete containers, 7 of them, put them on a storage pad, keep them there until the repository is available. They said, what are you going to do about shipping? So they said, we're not going to approve your CDR because you need to incorporate shipping. So this optimization study, we're right in the middle of it. We've identified some shipping capability, what commercial spent nuclear fuel is using, the type of equipment, cranes, shielding, how they move, how they load on a rail car. So we're incorporating that in the Glassway storage process.
So these will be able to be transported as a unit?
Yes, in the future, what we'll do is we'll take them, the SCT will take the canister out of the storage container, back up and pull into a bay right next to it, and there'll be a NRC transportation cask underneath that floor, and the SCT will drop it down into the transportation cask. And that's in a future, that's a phase 2 of the Glassway storage.
So these containers are not transportable?
No, these are storage containers not licensed by the NRC. They're strictly for storage. That means we'd have to go to the storage pad, bring them back to the transfer facility, and transfer them over to an NRC transportation pad. Okay, introduction, background. Steve McMall, it's my honor and just have so much fun being a federal project director. I love working on this project. Been working on it since 2011. I've seen the rise and fall and all the different opinions on this. So what I want to do is give you guys a level of confidence that the Department of Energy Savannah River has a very strong strategy for glassway storage here at Savannah River for the entire life of the liquid waste campaign. I'm going to go over some schedule activities of the funding profiles and issues. Again, as you know, it's tough to read the federal budget, so we have to throttle our project. We have to be ready if some money comes to us. We have to be ready to roll with the money and be able to produce. We're also going to show you a canister production chart. That chart, which is in your package, and we'll go over that later, shows you the generation rate of DWPF canisters per Liquid Waste System Plan 19 versus the number of available storage positions in Glass Waste Building number 2. And when we get to it, you'll see that line coming down to 0. That's when we need to have storage capability. But we're going to be ready before that happens. And then there's going to be some support information. What's the transfer station looks like? What kind of equipment that we're going to need to load and to move these canisters and storage containers. Next slide. Okay. Your eyes haven't gone bad. It's kind of fuzzy, and it's fuzzy in your pamphlet. This is the existing Glassway storage building. This is number 1. Number 2 looks just like it. They hold 2,200 canisters. This is the proposed storage pad for Glassway storage project. And as you can see, it shoulders right up to Glassway building number 1 and 2. The transfer station is this little thing right there. Do you have a pointer?
You did it for you.
Oh, you are?
That's forward, backwards, in and treatment.
Okay, right there. That's the transfer station. So the SCT, which is parked right here at DWPF, will pull into either Glassway Building 1 or 2, bring it to the transfer station, put it into a container, and a container mover will bring it over and put it on the concrete pad. These are what spent fuel. These we went and looked at 2 commercial nuclear electricity producers. This is how they're storing their spent nuclear fuel currently. These were taken last winter. So that's what our storage containers are going to look like. And these are storage containers. These are not NRC transportation cabs. All right, here's the famous chart. There's the numbers for Liquid Waste System Plan 19. You can see that in FY14, did we get 126? 126, even one more than I wanted. And so what we did is we charted the production of Glassway storage per System Plan 19 and the number of position slots available. Right now it's 715. So you can see by January of 2019, we're going to run out of space in the Glassway storage building. So in order to make sure that we can keep DWPF operating according to the system plan, once you get a melter running, you don't turn it off until something breaks. We're gonna make sure that we have storage capability, adequate and safe storage capability, so we can keep that melter running and keep producing cans. All right, project background. Here we are. We were CD1, approved March 2010. All of a sudden, here comes headquarters saying, well, due to flatlining of the EM budget, you're going to have to come up with something better than the Glassway storage building number 3. So we came up with SIF, the canister interim storage project. In our CDR package, the numbers range from 40 million to 64, compared to 140 million for Glassway storage building number 3. We've got some pats on the back for that effort. Savannah River did a great job on it. Okay, so we produced a CDR in February 2013, sent it up to headquarters. Headquarters said you need transportation. So in FY14, we're doing an optimization study to take the SIS concept, and now we're putting transportation into it. And what we did for the optimization study, we did an expression of interest for anybody who knows about spent nuclear fuel. All the big spent nuclear fuel suppliers responded, and what they told us was that our SIS that we did the CDR on, was a valid concept. That you guys with the transfer station and putting them in a storage container and putting on the pad is just what we do in commercial spent nuclear fuel. So we said, yeah, we're right on the right path. So now we've got this optimization study that's saying, okay, now figure out how you're going to be able to ship. When that repository, Yucca Mountain, or wherever it's going to be, opens up, we want to be ready to ship. So that's what we're doing right now. So that report is going to be done Thanksgiving time, sometime early December, and then we're going to take that package to the acquisition executive, which is Dr. Moody. We're going to reaffirm CD1. And that package, we're going to send it up to headquarters and say, hey, this is the storage strategy for the liquid waste campaign at Savannah Riverside. And it's going to incorporate storage, up to 4,000 more canisters than what the Glassway Building 1 and 2 can do. Because there's 8,500 canisters that we're going to be producing, and only got room for 4,500. So I'm going to have some kind of storage. So we're going to put that package up there in front of Dr. Moody, and he's going to sign off and it says, yeah, you guys are good to go. So we just got to wait on some money. So in FY14, we're doing the optimization study. We're going to complete that in November, and that's going to really tell us what we're doing for our storage and shipping strategy for the liquid waste campaign. 15, we're going to reaffirm CD1, and if we get funding, we're going to do preliminary design and request for proposals. So that's about all this engineered equipment and overhead cranes and canister mover container mover. So, you know, we're going to have to compete with the commercial spent nuclear fuel industry because we're going to be using some of their equipment. And if the schedule holds tight, in 16, we're going to get the RFPs in, request for proposals. We're going to evaluate container because there could be many ideas about a container. How are you going to lift them? How are you going to put the top on? How are you going to keep the canisters from rattling in there? A carrier. These containers with 7 canisters in here are going to weigh 126 tons. 126 tons. So you're not going to be able to pick them up very easily. And spent nuclear fuel industry does it all the time. That's why I'm saying we're going to be utilizing some of their technology. So then we're going to begin fabricating the container because the project is going to pay for 2 containers so we can test, train the operators, make sure that everything is squared away, and then we're going to buy the extra storage containers based on the production rate of DWPF. We're doing about, well, 125, you know, one every other day or one every 3 days. So these are going to hold 7 canisters. So we're going to need, you know, a container, 2 containers a month. You know, again, it just depends on how fast we're producing them. In FY18 container, we're going to start working on a transfer station, great big, lots of concrete, a road. We've got to bring in fire water, not fire water, but water for fire, and build a storage pad. FY19, we're going to complete the station, the storage pad, the road. We're going to do the startup testing and ready assessment to see CD4, and CD4 is turning it over operations, giving these guys a new mission. So what's the issue? It's really funding. You know, we all know that. We see that every year, continuing resolution right now. When are we going to get money? Everybody knows I've briefed headquarters, Jim and Gene brief headquarters about how we're filling up Glassway building number 2. They know we dropped dead in January 19th, so we need some kind of storage capability before that. All right, now I'm going to give you some supporting information. What's involved in this project? The site plan, you're familiar with it, going right down next to Glassway building number 2. What the container looks like, container transfer station, and the transfer process, and the canister transfer equipment. Okay, the scope of project, we got to have a functioning facility. We got to relocate some power. We got to move some buildings. We got to take a couple little storage buildings out of the way. We got to replace a storage pad. We got to do some site prep because if you're familiar with DWPF, got a lot of land to grade so we can get a nice flat surface to work on. We're going to start pouring concrete. We're going to build a transfer station, storage pad, container storage area, you know, the fence, the container fab area. And since these things are so heavy, we thought we could form them up on site and just bring the concrete trucks in and build them right there on site, right next to it. Because at 126 tons, you're not going to bring them across the road when you're at 80,000 pounds over the road. Then once we get all that concrete done, then we got to do balance of plant. That's all the tie-ins, the consoles, the power, the phone, the public address system. We got to have all the safety and communication as we do with all the other facilities. Then we got to get this engineer equipment. That's the transfer car. It picks up. The transfer car is a little rail car where you put the storage container on and it moves into the transfer station. We close the door and the SCT puts the canister down inside the container. We got an underhung trolley and hoist. That's to take the top off the container. Because if you open that garage door, there better be some shielding on top of that storage container. We got a container carrier. That's the thing that's going to pick up that 126-ton container, drive it down the haul road, and put it on the storage pad. Then we're going to have operator console and cameras. We're going to have cameras so we can watch the canister going down into the storage container. We're going to be able to watch the container go outside. We're going to have this to make sure the top is on before we open the garage door. Transportation capability will be installed in phase 2 of the project. That could be 20, 30, 40 years. And what we're thinking is that there's going to be a lot of technology advances because all the commercial industry is going to be doing the same thing, is storing their spent fuel, dry storage above ground in concrete containers. So we're not going to design it now. We're not going to make our selections right now. We're going to wait for the industry to advance. Then we're going to take advantage of what those guys are doing. All right, here's the site plan. There's Glassway's building number 1, number 2, this DWPF over here. There's the transfer station, as I showed you on that picture earlier. There's a great big storage pad. Here's an empty container staging area. This is probably where we'll be pouring the concrete into the storage container. So this right here is going to be a turnkey facility to make sure that we have adequate storage for canisters. All right. This is what a storage container looks like. Concrete reinforced, 30-inch wall, 12 inches diameter, 15 feet high. That's based on the size of our canisters and the radiological dose that's coming off those canisters. The container weighs 106 tons empty, 126 tons loaded with 7 canisters. So you're pretty serious doing a critical lift on this. Preliminary consolidated hazard now indicated due to math. Those 7 canisters are going to be sitting in here, very low center of gravity. They're not going to tip over. You know, we did all kind of analysis. High winds or tornado, they're not going to tip these things over. You can see these tops are battened down. And as a matter of fact, when they had that big earthquake up in Richmond a couple years ago, I called a couple of liquor places up there, and their dry storage didn't even move. They said they could see the roads moving, the buildings moving, and their containers sat square on the storage. This is kind of a cutaway view of what the container looks like, and with the canister sitting in there. We've got some vent holes in there, and these, again, this is a concept. We want that top sitting down with a little notch in there to make sure we're not letting any dose get away from us. All right, here is our high-tech DigiLoop garage. 2 floors. That's the bottom floor. That's the FCT. The shielded canister transporter has a shielding tube. So it picks up a canister from DWPF. It has a shielding plate that goes underneath it. It walks it out to the transfer station or to the Glassway storage buildings right now. And there's a hole in the floor. You can see the little holes in the floor. And we're going to have electronic eyes. And this container, since we're going to have 7, 2, 3 across, and then 2, we only need 3 positions on the floor. You just move the container back and forth. We're going to have cameras looking down in there, make sure everything is indexed properly. There's going to be a garage door on this floor, so we can close the door and load it. There's going to be a road sitting right here, and the transfer car will pick this thing up and take it down the road to the storage pad.
So they're going to be, canisters are going to be touching?
No, we're going to have a basket in there to keep them from touching each other, a stainless steel or a galvanized basket, kind of like a potato or onion basket that you have in your kitchen. And that basket will keep each canister from touching and rattling, and it'll keep that stainless steel canister off the concrete floor and off the concrete walls. That was one of the options we looked at. We went to West Valley. They have a shielded solid stainless steel with, it looks like a pistol revolver cylinders with 5 holes in it to pick it up. That costs $250,000 each one. And so we said, why put the shielding and the lifting capability in 428 containers? Let's put the shielding around the container and have a lifting basket and use the SDT. So with our concept, we're saving about $250,000 to $300,000 from what West Valley is doing. This transfer cart is the piece of equipment that will be rolling inside the transition, and that storage container will be sitting here on top. We'll have electric eyes watching these wheels, be able to, back that thing properly. It'll move back and forth. until the container has 7 canisters in there. We'll move it forward to the overhead crane, put the top on it, secure it, open up the garage door, and it comes out of the garage door. This is the container carrier. That is a spent fuel dry storage cache right there. They weigh about 150 tons right here. This is like a U-shaped. They have these things remote control now, so you don't have to have an operator up there. These things just go right, go right around the canister, the container, and pick it up, and then walk it right down to the storage pad. They move about 2 miles an hour, kind of like the same speed as Kennedy Space Shuttle mover. Whoops. These buttons. That's the Sheila Canisters SCT. These are existing. That's inside the Glassway storage building. That's a shielded transfer compartment right there. 250,000 pounds of this equipment weighs. One of a kind. Replacement value, $3, $4, $5 million. So we got to watch out working that thing to death. Okay, what's the risk? Everybody should know this. Completion of the Glassway storage building before storage room runs out at Glassway building number 2. So, what's the opportunity? It's a multi-purpose project. We're going to have storage and shipping considered in the design, and it provides canister storage for the Life of the Liquid Waste campaign. What are your questions? Yes.
Well, to begin with, I'm so relieved to see that all of this is going to happen, because over the last 3 or 4 years, the CAB has recommended everything that you talked about tonight.
Mm-hmm.
And strangely, we continue to get responses over Dr. Moody's signature that were, let's call them paper stone walls. One question I do have, I have several, but I'll make room for everybody else, is after we get all of this done, the buildings built, the canisters, the dry canisters put up, and the equipment designed for the transportation, when and where is it going to go?
I'm looking at a crystal ball right now. It's unknown. We'd like to see it, they're right now they've got the blue ribbon panel. They're looking at public perception, public acceptance of a new repository. And we've got Yucca Mountain that we spent lots of money on, but at this time we don't know where it's going. So the whole commercial nuclear industry is doing what we're doing. We're going to be storing this in a safe manner. We're going to be monitoring them and inspecting them, and we're going to store them here until a repository opens.
But this site has never been tested, studied, or licensed for long-term nuclear waste storage. So if it can't go to a repository, and that's 8.5 presidential campaigns from now. So if it can't go to a repository, why can't it go somewhere else?
There is, DOE is looking into interim storage sites. And, again, it's public acceptance. There are some places out west that are volunteered to be a interim storage place.
What places are those?
Well, I know WIP is looking at it, so is Texas, and I believe Oklahoma's looking at it. So there are people coming up saying, hey, we'll take interim storage.
Are any of those licensed to do that?
Not at this time. Not this time.
I have a couple of questions. First off, you have to need a shipping, or a shipping dock. Is this going to be able to double as a shipping dock?
Yes, we are going to have.
We're designing it with that.
Yes, yeah. The next phase will have an upender where it will take a NRC licensed cache that's fully loaded with 7 canisters. This upender lays it down in a saddle, and then we're going to have a crane that will be able to pick that cache up and put it on a rail car and that rail car will have 2 impact limiters on each end, and we plan on bringing a rail spur in. We can load the NRC transportation cast right on a rail spur, right next to the storage pad, and we'll tie that rail spur into the main line at Savannah Riverside. So we're going to be fully capable.
The other question was WIP. WIP's been thought of as a potential site for this. If WIP opens back up in 2016, and if this becomes a feasible option, with the dramatic slowdown that you've had in the production of canisters, it seems to me that you may be able to get some of the canisters out of Glassway Storage Building number 2 on their way to WIP, if you can get that kind of a plan pulled together in time.
Right. There's talk at headquarters about utilizing WIP as an interim storage. We've looked at how we would get a canister out to WIP. So I mean, it has been talked about. That is a possibility, but it can't be determined at this time.
But it should fold in. It should factor into your cost analysis. You may not be. You may not need space out there for 8,500 canisters.
Well, right now the liquid waste campaign is supposed to end around 2032, 2034, somewhere in there, at about 8,500 canisters, 8,750. That's going to be, 20 years from now.
But if they're moving in 2016 away from SRS, you won't need to put a space out there for all 8,500.
That is such a good comment. I am going to let Jim Folk address that.
Jim Folk, DOE. Well, that's the beauty of this design. It is a modular design. So all you're committing to at any one point is a storage container for 7 additional canisters.
Right.
So if you can once project, just as you're saying, a certain date and time, and we can start shipping, start relieving that inventory, that's all we need. As opposed to, back to the monument, if we were to build a large building, well, if it was built for 2,200 or more canisters, that's what you're going to get. You're either going to get exactly the
right. We're going to make storage containers as fast as we produce them. So if we get the word go ship to a repository, we don't have to have any more storage containers. We'll be ready to go shipping, and we can put the shipping capability in gear in about 2 3 weeks.
Steve?
Lee had his hand up.
One more.
Well, this has to be the last one because we have to move on.
Okay.
Okay, I have a question. I was trying to look at the long-term risk from this modular storage as compared to Glassway storage building, and I didn't hear anything from what you said about the long-term risk, the potential, whether it's better or worse than Glassway storage.
It provides the same ALARA and exposure capability as a Glassway storage building.
That's wonderful, but that's today. To get rid of it, and I don't know what it's going to be, but what's happened? What's the difference? What are the differences between glass storage in the building and storage in these modular units?
That has to be factored.
Risk-wise, I think it should be. I think we should hear about that.
Well, Lee, let me
Now, it's probably beyond my time, but he's been claiming I'm beyond my time already.
Well, Lee, there should be no preconception that this is going to last 10,000 years. Okay, this is meant as a design life, just like the building's 40, 50 years is kind of what we designed to originally. If we hit the point where there would be some long-term storage, we would have to revisit that whole equation. Right now, what we have is a storage for a prescribed amount of time. Anything beyond that, we'd have to go and look at.
But the question that you need to be defending is the differences in long-range storage risk between Glassway storage building and these modular units. That's all you're doing. That's the difference between.
But the modular units provide the same storage capability and can be reproduced faster than you can build a Glassway storage building.
Well, I'm not worried about that. That's the point he's trying to make. The point I'm making is, will they corrode and will the waste be discharged in the future sometime due to some long, slow
We've looked at the durability of the stainless steel canisters and the glass form, along with the electrolysis and the corrosion factors inside inside the storage container, compared it to the steel storage positions in the Glassway storage building, and to provide the same long-term.
That's what I was trying to get you to say, is you've looked at it and there are no differences. That's really what what I'm hearing.
That's not what I'm.
But I would love to hear that stated clearly.
The NNSA or NRC, I've forgotten which, has a site where they're reporting all the problems they're finding with the dry cast, corrosion around bolts, freeze-thaw, cracking. Why will these not be subject to the same kind of problems that all the other cement dry cast systems?
Well, we're going to be monitoring, surveilling these containers. We got the transfer station. If we see a problem, we can make a storage container in less than a week. So, but by the time you form up the concrete container and pour the lid, you can take that to the transfer station and you can transfer those 7 canisters into a new storage container.
But if there's something that you're doing and a risk you haven't thought about, and that's the question, you need to be able to answer that question, because it's going to come up over and over again.
We've done a consolidated hazards analysis and a safety review. We've looked at all that. We've got a risk register. We've looked at long-term, even when they designed and approved the stainless steel canisters for both Savannah River and West Valley, they looked at the long-term durability of those canisters.
I presume that's true, yes.
Okay, gentlemen, we have to move on. We have another presentation. Steve, thank you, sir, for conducting. We'll now have the crawling along the waste tank sampling technology demonstration by Jolene Sykes and Greg Arthur.
Hey, why am I sitting here next to you? Unlike Steve, we weren't invited. We begged to come. So we're actually going to do a show and tell tonight. We brought one of the crawlers that obviously it's not one that's been in the tank, but before Greg comes and does show and tell and shows the video of actual sampling that was done in some of the waste tanks recently, I just wanted to remind everybody of some things. So hopefully this is a little interactive here, but it's kind of funny because DOE management didn't even ask what I was going to say tonight. So back in the day, there's an EIS, right? And the EIS used the terms clean and empty. So I want you to think about what is clean and what is empty. So I ask you to think, if I took a plate and set it on the table, is the plate clean and empty? It depends. I took it out of my cupboard and put it on the plate, it's clean, right? Presumably it's been through the dishwasher, so it's clean. If my child just ate off the plate and is asking me, can I leave the table, what are we going to say? When your plate's empty or when your plate's clean. It's not a clean plate, okay? So remember, the tanks have had waste in them, has liquid waste, the supernatant, or liquid waste, which is going to be in forms of liquid, the supernatant, the salt cake, which is a solid, and the sludge, which is a solid, right? We're going to take the bulk of the waste out. So we now refer to things in terms of waste removal and waste retrieval. So we're removing the bulk of the waste and removing the heel of the waste. And one term that we do use cleaning for is when we talk about chem cleaning, using acid. So kind of imagine you had a coffee pot or a teapot and you boiled water in it over and over and over. What do you get this hard water deposit? Women in the room, what typically do we use to get rid of it? We use vinegar, right? We use acid treatment. Does it always get rid of all the residue? Probably not. You know, my husband told me, I actually did this week. I was trying to clean this teapot, and I said, I should take this teapot to CAB and show this, you know, we could peek through the little hole, and he was like, don't do it, don't do it. So think about what clean means and what empty means, and think about that when you see this video, because These are cleaned, in theory, empty tanks that we are going to be grouting or have grouted. So he's got video of 5 and 6. Did you bring 18?
Yes, I got some of 18, 5, 16, and 12.
Okay. And so 16 and 12 are the next 2 tanks that we're cleaning and preparing to close. Okay? So that's really all I had to say. And so I'm going to introduce Greg Arthur from SRR Closure Engineering Group, and his group is the ones that have designed the crawlers that have went down inside the tanks. They produced a fact sheet to take with. So with that, I'm going to turn it over to Greg. And afterwards, and I know you have something to do, follow up after this, but you are welcome to come up, touch the crawler. I guess you may want to try to drive it, see how, if you can. Now remember, there's a lot of obstacles in the tanks, and that's what you're going to see, what this poor crawler has to go through. Thank you.
Thank you.
All right, thank you. As I said, my name is Greg Arthur, and I am going to try to explain a little bit and show you how the closure sampling process has matured as we go from one tank to the other. Basically, we're going to do that in 3 different ways. One, I do have the fact sheet that she mentioned. We're going to go through that real quick, and this fact sheet is basically on the current crawler we use. Then we're going to go to the video. The video is going to show, as we stated, from the early phases where I actually didn't use this crawler. I used a different one in tank 18, then how it matured through tank 5, tank 16, where we did a little bit different because there were some, tank 16 was a little bit different there, basically related to the amount of material and the difficulties in retrieving it. And then on into tank 12, which we got even a little bit more complicated because there was some liquid left in it. So the first thing I'd like to do is go ahead and talk about the fact sheet. If y'all, do we have a picture of it, or is it just on the paper?
On the paper.
There's some more back there if you didn't get a copy of it. But the fact sheet, basically on the first page, it shows the crawler that we're currently using. Now, the crawler is an off-the-shelf pipe inspector that's used in the petroleum industry that we adapted to be able to pull samples with. It's an Untitled 450. It's a neat little crawler. Usually it's made out of aluminum. It's built by Untitled USA. They're based down around Baton Rouge, Louisiana. Now what happened was when we got the crawler, because it is a pipe inspection crawler, and we wanted to adapt it to be used in our tanks, we had to do some modifications here on site. We did some of the modifications early on. We used it in one of the tanks, realized, okay, we need to do some more. But basically, if you look at this first picture on your paper, that's straight off the shelf. That's what it looks like coming off the shelf. The second picture over here shows some of the modifications we did to it. Those modifications and why we did them will become obvious to you as we start watching the video. Now, the second page on the fact sheet is just a little bit of an overview of some of the challenges that we see as we go through the tank, as we start sampling the tank. You'll see those more clearly on the video. So let me set the stage for you of what we're doing. And I understand most of y'all have been out to the tank farm and have seen the top of the tanks and everything. Well, the tanks that I'm talking about, for those of you who have not, these tanks are large underground tanks. They're about 85 foot in diameter. So if you look at this room, probably a little bit out past that far wall over there. They're anywhere from 35 to 40 foot deep, depending on the ones we're talking about. So stack 2 or 3 of these rooms on top, look up, and that's how big they are. Now the challenge is, first off, accessing the tank. Even though I have these big tanks, the access to the tank, I'm very limited to the openings that we call risers. The biggest risers that I have are like 23-inch openings. So if you look at on the second page, the first picture here, that's actually a picture of one of my crawlers going down through this 23-inch riser. Very difficult, very tight. So then once we get it into the tank, and this is really the reason we use this crawler, you can imagine in this room, there's the riser over here, and I'm lowering the crawler down, but I want to sample from over there underneath that clock. So the crawler comes into the tank. The guys on the team who run the crawler then start driving it across the tank to go over there and pull the sample. On the first sample we pulled on tank 18 and 19, that was fairly easy. The tank's wide open, it's clear, there's no obstructions in it. When you get into the next tanks, 5 and 6, 16 and 12, it becomes a little more difficult. And if you look at this picture, it'll show you what we run into. There's a forest of cooling water pipes that go from the top of the tank to the bottom of the tank. They're run horizontal all along the floor of the tank. So we have to navigate around those pipes. Then the last two pictures are just where we're at now on tank 12, where we're actually using two crawlers in conjunction with each other. We're pulling samples out of water, so forth and so on. So we'll go ahead and start the video now, but let me give you a couple of cautions, if you will, about the video. As we go through the video, you're going to see different colors and different textures on the material left in the tank. A lot of that is from the type of lights we use. It's really the same material, but you're going to see it look a little different because there's different tanks. As I move from one tank to another, I use a different light, different type of light. It changes the color down inside the tank. It changes what the cameras were seeing. Also, when you watch the video, you're going to see two different shots, and I'll try to highlight that for you as we go. One of them, our crawler has a very nice camera on it. It's a very good camera. It's able to zoom and do all this kind of stuff. However, it distorts the image a little bit. Things actually look bigger than what they really are. So as we're going through, I'll try to highlight that a little bit from you. A second type of shot that you're going to get is we actually take cameras and drop them down through the risers so we can have this overhead view. Crawler moving around. So if you would, go ahead and start the video. First thing we're going to show, I'm going to back up over here so y'all can see that. The first thing we're going to show is the early sampling. This is in tank 18. Like I said, there's the crawler being lowered. That's the early version of the crawler. That's not this one. We found out after sampling 18 and 19 that we really didn't want to pull the crawler up and down every time like we're doing on this tank. So that's when we went to this crawler. This crawler goes in the tank. It never comes out. It never sees the light of day again. So that crawler goes in the tank. It stays there. It's grouted in place. This is an example of some of the problems that we ran into maneuvering the crawler. These are some hoses that were left down in the tank from the waste removal effort. And in actuality, the person running this crawler right here is sitting right back there. It's Tim. He's kind of hiding from me right now. But Tim's one. He's been with me doing sampling these tanks all along. Now this one is tank 5. This is the first tank we used this crawler on. And notice all around here. That's all those cooling coils I was talking about. There's a view of it closer to the bottom of the tank, and you can see it's kind of even hard to see the crawler as it comes in the tank. There's just so many pipes. There's a sky view of the crawler actually hitting the bottom of the tank, and it's going to crawl off here and come off that hook in a little bit.
How did you determine where you needed the sample?
We worked with a group we call CWDA. They work with SRNL based on where the material is, whether there's some accumulations or what have you. We do a statistical analysis for it, all that, and we develop a map. That map is given to the guys who sample, and then they go off and move the crawler from one spot to the other. Now this, and we can talk a little bit more after that, this video moves pretty quick, but this is a good view of the obstructions. So if I come in, like I said, here and go to the back wall, in the tanks, I've got to work around these pipes running horizontally and so forth. Now this is actually a video of us pulling a dry sample out of tank 5. So there's our crawler, there's our sample cup, and that's the material we're trying to get a sample of. So what the guys do is they extend the arm out, lower the cup down onto the tank bottom, and then just basically scrape. If any of you guys are like me, it's basically running a backhoe. And that's all we do. You just pull it in and take it up a little bit. In just a second, you'll see him pulling it back towards you. That right there is a tether we'll talk a little bit more about. That's a horizontal coil running along the floor. That's one of our vertical coils that we run into a lot. But there is the sample vial. That's the sample material, or the material in the bottom of the tank being pulled up in it. And you can see it's being drug along right in there, obtaining our sample for us. Now, I'm going to show a little bit right here is some of the challenges of moving through the tank. Again, look at the coils that are all through there that we're having to fight. Some of these vertical coils come down and they loop and they go back up. They form these loops. There's several horizontal coils here. And in this video, the crawler, this is the crawler camera, and he's going over the horizontal coil here. So what they're going to do right here is they're going to lower the camera down because we don't want to break it as it goes over. And then the crawler will go over the top of that. Now, as we watch this, I want to make one mention. One of the nice things about this crawler is it allows me to pull 3 samples at one time because we have a little basket we can show you a little bit later on. So we go down, we pull 3 samples, put them back in the basket, we take them back to and here's actually the crawler fixing to go over, and it's a little bit violent and it falls. And I want you to notice, look at that coil right there. That crawler is actually sitting on top of that coil. Now I got to get the crawler off of that without getting it stuck and then move on. So what I was saying, and this is Tether Management. The crawler is powered through this cable that sends the power for the track, that sends the power for the camera, the recording and everything. That follows along behind me. So as I'm weaving my way through the coils, I got to prevent that tether from getting tangled up. We spend probably 90% of our time working with that tether, that piece of wire, trying to keep it from getting tangled in those coils so we can keep moving on. And what he's doing with it right now is he's pulling the tether along. We're actually by the edge of the tank right here. You can see that's the tank wall. He's pulling that tether along, trying to get it loose to where he can move the crawler on a little bit further to our next sample location. And he's fixing to drop it, and then we'll move right on. And he's fixing to drop it. There it goes. Okay. All right. Let's see what we got next here. All right. Now, for tank 16, remember a while ago I said in tank 16 it was a little bit different. If in tank 16 we didn't have a whole lot of material in the primary tank. In fact, it was very limited on the material. We did have a lot of material in the annulus duct. This is what this piece of pipe you see right here is. That's actually a ventilation duct that they use to pump air down inside the annulus to keep it dry. Our challenge was, and here's another picture close up of the ductwork. We had material inside that ductwork we had to get out. So what we did, as you can see what right here, that's actually a hole saw. We're cutting a hole in that duct. Now also keep in mind that as we're cutting this hole, the guys actually doing that work are 40 feet above this piece of this ductwork. And they're doing this through an opening that's 8 inches wide. So we've cut a hole in the duct. Now the next problem is, okay, how do I get that material out of there? So we figured, well, the best way to do it was to vacuum it. And so what we did, we don't show it on the video, but there's the material that we're going to try to sample. We came back in, broke that material up with a little auger. Then we actually took a vacuum cleaner. That vacuum cleaner is a Bissell vacuum cleaner, just like you can buy at any Lowe's or Walmart. We took that vacuum cleaner, we put it on the edge of a pole, on the end of a pole, dropped it down into that hole, and just let it suck the material right up. And that's what you're seeing happening right here. We also, inside the primary tank of tank 16, since there was such, there wasn't a whole lot of material in there in accumulations, it was very difficult to sample that tank. I don't show it on this video because of time, but we actually took that same type of vacuum cleaner, let the crawler carry it around, and vacuum material up with it inside the primary tank, and then we just pulled it out. Now we also had some other situations. This one happens to be with tank 12. On tank 12, when we first started looking at sampling tank 12, we noticed there was some material that we hadn't seen a whole lot of before on the cooling coils. We didn't know what it was. So we decided we were going to go ahead and try to find a way to sample it. What we did is we built this little apparatus, and if you notice, there's another one of our famous Bissell vacuum cleaners right there. And what that little apparatus will do, and you can see a little bit better in a little bit, is it came down, it was horseshoe shaped. It came down, it wrapped around the pipe. Inside of it was some wire brushes and a scraper. And you can see we're actually running it. The video will show it going up, but we run it up and down, dislodging the material from outside the coil, and then our little vacuum cleaner just pulls it right up. And it was very successful. We actually got some good sample material from that. But we developed that on site and built it on site. Engineering, construction, and the RADCON. Now here's tank 12. This is the last tank we just got through sampling. This was the first time we ever did it. If you notice in the bottom of tank 12, there's liquid everywhere. That's the first time we've ever had to do that. But, so I had to go in there, pull samples with liquid, and I still had this spaghetti bowl of pipes to navigate through. Now here's another, this was looking up from the cameras that were hung from the riser. That's our crawler going over a coil. And the reason I left this one in here is I find this one a little bit interesting because as he starts to go over, watch what the crawler does. It'll go to the right. It actually shifted on us and fell back a little bit. And what that was leading us to is that's the way we get our crawler stuck inside the tank. They can straddle over the top of the pipe. And what you're going to see is in a minute, this crawler is just going to sit here. And I really got to compliment the guys who were working on this because what's going on in the background, which you can't see from this video, is, all right, I'm in a little bit of a sticky situation here. So the engineers, the guys in the field are all getting together and they're talking, okay, how do I save the crawler? How do I keep it from getting stuck? How do I keep from losing it? And eventually they're going to go right on over. And then they move on. Right, the next one, we're pulling a wet sample. It's basically the same thing you saw with the dry sample. The crawler's going to extend its arm out and pull back. However, there's a couple inches of water over the top of it. The most difficult part about this is actually seeing if we got good sample material because the water obviously is sitting on top of it.
Is that rainwater?
Sorry?
Is that rainwater?
No, sir. This is actually water that was left in the tank after we did the waste removal. All right, now this one's good. This is Joey was talking about some of the material that was left in the tank. This particular material was actually behind a very large number of cooling coil pipes, which limited the impact our mixing foams could do to it. So what we're doing here, the crawler is going to reach out and it's going to scoop up on this thing. This is also a little bit of what I'm talking about, the camera distorts it. This picture makes it look like that bowling ball of material, if you will, is pretty good size. But in reality, it's only like maybe 6 or 8 inches across. It's not that big of a mound. And you'll see the crawler starting to scoop it up. One of the things that we found, this material was a very, very pasty type material. It's very sticky. Was not easy to, matter of fact, the lab had a difficult time getting it out of the sample bottle that we have right here. Getting to this particular area was a challenge for us because, and we're going to highlight a little bit more here, is we actually got blocked from all the access points to this area by cooling coils that I've been talking about. And so what we had to do, and this is the first time we ever did this, and there's the cooling coils that blocked us from getting back there. So we actually had to use 2 crawlers. This is one of the crawlers that actually took our sample vials here, dropped them over the cooling coils, and now here's our second crawler that's been in the tank for a while, and you can see kind of dirty. It's going to grab the basket with the sample vials in it. It's going to take off and go and pull that sample. That was actually the crawler that you just saw pulling the sample. So now I've got 2 crawlers down in the tank working tandem with each other. Here we pulled the sample. It's coming back over, and it's going to hand it back off to that other, the first crawler. That was unique. That was new for us. It was kind of, we were really perfecting that one as we did it, as we worked here. And I believe this is going to be the end of the crawl of the video. So what this video, we tried to show with this video is we started off with tanks 18 and 19. And Tim and Greg, if y'all want to come on up and go ahead and cut this on while I talk this a little bit. What the videos we tried to show is on tanks 18 and 19, I had a single crawler pulling one sample at a time. And then the crawler and the sample all came out together as one unit. We didn't really like that because we wanted to reduce the exposure to the individuals that were handled. Well, they never really actually handled them, but they were getting the samples packaged and sent up to the lab to be analyzed. So we came up with, all right, let's use a crawler that can obtain the samples. We said, well, let's get 3 of them at a time. They'll pull them out 3 at a time, reduce the exposure to the individual workers on the tank top, as well as being easier to get the samples. And what I'm going to ask Kim to do for us, I don't know if y'all can see this, but he's actually going to cut the crawler on and actually let it operate for you. Now there's, what he's raising now is the camera. That's the camera that you were seeing the actual video taken from. Now I do warn you, if you're going across this carpet, you're going to hear the crawler make some clicking noises. Don't let that alarm you. It's actually a clutch inside the tread. Keeps the
It's not radioactive.
Oh, absolutely not. No, this one, you can tell this one's really clean. There's that clicking noise. That's actually a clutch in the tracks themselves, keeping them from putting too much force on them. Now what I'm going to do is I'm going to actually ask Kim, this is an example of the actual sample basket that we use to pull the sample. So there's one of our sample vials that we were using. And I'm going to challenge Tim, if he can, to go ahead and take the arm on this and try to pull out one of these samples for you. However, and Tim didn't know I was going to do this thing, this is really not indicative of how we do it in the field. Main reason is because you can see the quality, you can see the sample. So Tim, if you would, turn around and just use the screen.
Yeah.
You can't look. Now, if it's all right with you, I'll go ahead and open it up for questions now while he demonstrates this.
Oh, yeah.
Fun.
Yeah.
Subject to be any questions.
How do you handle the ruptures to those pipes, those
The rising.
we call them spaghetti pipes?
Yeah. Right.
If they rupture and if they crack, how do you handle those scenarios?
Well, with the sampling process,
Right.
the pipes, by the time I go in there and sample, the pipes are already drained, for which if they're broke, they've already been drained. And usually when the material that's inside the pipes, when they drain out and if they get broke, goes out with the waste removal. So wherever that we remove the waste, it usually goes out with them. So usually when we go in there and start sampling, if there is a broken pipe, and there's quite a few of them, those pipes are already, and I don't have to deal with it at the time of sampling.
That's it. Okay.
What's the cost of the loss of each one of these cameras each time you just grout one in place?
We bought a crawler. The crawler. We bought the crawler. We bought our last crawlers probably about 2 years ago, and the individual crawler itself, just this unit right here, was between about 80,000. And then when you add the controllers into it, it gets up there to about 110. Now, this is the same controller. This controller was actually used on tank 18 and 19. Not in the radioactive area, but out in a trailer, the clean area.
Because I saw you had 2 of them in the tank, so
Correct.
That means they will never come back out.
Those 2 crawlers are still down there in the tank. Any other questions? Yes,
I have a question.
Yes, sir.
Tank 16.
Yes, sir.
Tank 16 leaked and material got into the annulus pan, the pan underneath the tank.
Yes, sir.
How do you know how much what the risk left was when they've cleaned it now,
Yes, sir.
as I understand it, and so how did you measure what was left after cleaning?
Well, that's the whole concept behind pulling these samples.
No, sir. I'm talking about under the tank this thing was running on.
Oh, you're talking about underneath the...
In the annulus pan. It's an annulus. It forms the pan. It's the out of surface. Now, how do we know what's left there?
Oh. You know what? Yeah, it's estimated, but I don't know the details on how they estimated that, so I'd really hate to get into that, because I'm not the expert on that. I don't know really how to answer that question.
Well, you know, I'll address this to the CAB. That's a question that comes up over and over again, and nobody has answered it. So, you know, why don't the CAB ask for a presentation that would help us understand that?
Good job.
We don't have to ask for a presentation.
You get it? Got it. Yeah, nice job.
Okay, now put it back.
Are you gonna pay raise for this?
He makes too much money as it is now. So.
He's done over.
Excuse me, we don't have to ask for a presentation, we just have to ask that you get back to the CAB with that information. That's the tradition. I'd like to ask about, you mentioned, the sampling strategy and the statistical analysis. What kind of variables are in that strategy?
Oh, it's a lot. There's a lot of variables in it, everywhere from the physical layout of the coils in the tank. Like, I'll give you the way we do it. What we'll do is we'll sit down when we get through with waste removal. We'll go in with the camera. We're going to look around in the tank, and we actually map. And when I say map, we try to estimate the best as we can where the various accumulations are, where they're not, and so forth. So once we find out where all of that is at, then we take a look at how the cooling coil piping is run and where the cooling coil would block us from getting to some where there's not an accumulation. And then also those risers that I was talking about, the 23-inch opening, which one of those are available for us to get into. So you look at all that variability, those variables on how to get to it, whether I can get to it, whether there's material where I can get to. You put that all together. You do a little statistical run on where the material is at, and then that's where they come up with which ones we're going to pull and where we're going to pull, and how many we're going to pull.
Is it characterized by what you perceive as volume, or what? Are there different kind of materials down in there? There must be differences in what's left in the tank.
Okay, now we're getting way away from the sampling aspect of it with that question. We're getting in the characterization. Again, I'm not the expert on the characterization part of it. That's handled by another group. And
so I mean, relative to the sampling.
Okay.
You have things down there that look like they're in volume.
Right.
And you have other things that look like they're not necessarily in volume. But how did you kind of characterize it to determine what you wanted to sample?
Well,
volume?
A lot of it is based on volume. Most of it is based on volume, but more of it is based on where the material is located inside the tank and whether or not can I get to it.
Accessibility.
Right. So I may have a little accumulation over here, about maybe a ½ inch deep or what have you. I may have another accumulation over here, again a ½ inch deep or what have you. But this one is completely surrounded by these pipes. Well, I can't get to that. I'll leave that alone, and I'll go over here and I'll pull this. And that's where the statistics fall into it.
When they take the samples, so they have samples in tank 12 from the cooling coils, samples off the floor, which were a very thinner layer, and then a mound like that clay type material. Let's go up to the lab. There's a sampling protocol that is used to composite those samples to make. So some of the floor sample is mixed with some of the clay mound sample to get a distribution, and then that's run in the special analysis. So kind of what we already remember, there's going to be closure modules. So there's going to be a closure module come out for public comment that the state of South Carolina is going to put out for public comment for closing tank 16 to address, well, how did we assess the risk, long-term risk, closing for grouting that tank, and what was left that residual waste that was left in it. The separate closure module come out for tank 12. It's tank specific. There's one tank is in the water table, or submerged in the water table. The other tank is 6 to 8 feet of the lower portion of the tank is in the water table. Where's the tank relative to the point of compliance? and all that in the closure modules that are currently being developed by the CWDA group that they keep referring to. So those are, we're in process right now of doing preliminary reviews with the state and EPA on those closure modules to get them prepped and ready to come out so the final decision to grout those tanks can be made.
Right.
I have a question. Is there somebody else? Go ahead.
Good question. It appears, and you could correct me on this, you're not able to do 100% sampling. Is that correct? Because of the pipes and obstructions and so on and so forth.
That is correct. There's already areas.
What percentage? What ideal percentage would you say you're able to sample from? Is it 70% of the tank? Is it 20%? What is it?
I'll give you, for tank 5, for instance, we were able to get, not easily, it was a real challenge, probably to, I'd say 70 to 80% of the tank. Tank 12, because of some of the coil, the conditions of the cooling water coil, it would probably have been a little bit less, probably 60 to 70%. There was one section in tank 12 that the coils were, just would not allow me to get to it.
Okay. Is there any technologies out there that would help you to remove that variance? Is there anything out there that I was just talking to my colleagues about the robotics, right, that's used by NASA and what we see millions of miles away and whatever, and they're using wireless robots and they're picking up samples and bringing back pictures. Is there anything that could help you in terms of removing that difference, that 35%, 20%?
I'll answer that question this way.
Accessibility.
Yes, and one of the things that I'm charged with doing is continuously trying to find that better technology that you're talking about. And we have looked very hard at wireless technology. We've looked very hard at the ability to go through and cut the coils. Everything from pinchers, shears, if you will, to liquid nitrogen, to just grinders.
Right.
They've all got good points to them. They've all got bad points to them. There's some things that are out there, especially there's a vendor or a company out there, a local or a company in the United States called iRobots. They've got some very nice technology that we're constantly watching. We monitor what the military does with their type of probes. We monitor what NASA does with theirs. Right now, for what we're doing, this crawler has proven to be the best. And I didn't really highlight it to a whole lot, but not only do I have instructions in the tank, but the material themselves can cause issues. For instance, the tanks are usually caustic. So, a lot of this technology you're talking about has plastic chassis or aluminum chassis. Well, that won't last too long. You saw how it got real muddy and stuff. One of the downsides for using wireless technology is I've got to recharge the batteries. The sampling you saw on tank 12 took me a month. I haven't found a battery yet that would last me a month. And then the recharging technology, because of the fact that it's very dirty down in there, it's just not inducive to recharging in the tank. So right now we're sticking with this, but we're constantly looking. As a matter of fact, we go to the state once a year and we make a presentation to the state that says, okay, here's what I'm currently using, here's what I've looked at, and we brief them on that exact topic.
Greg, we got one more question.
Yes.
What's the status, if you know it, of the standoff between the state and the Department of Energy and EPA on closing the next two tanks?
I do not know the status.
Newspaper last weekend.
Yes, sir. I saw the articles. I don't know the status. I would have to look to the.
Jim Folk again. We've, as you probably know, we requested an extension to that milestone. They took objection to that, both DHEC and EPA felt that those extensions were not appropriate, at least the time frame that we asked for. So now we've entered into a dispute resolution process that's prescribed by the FFA, exactly how you go through that. So we'll begin those at an informal level as kind of a first phase. We'll begin those discussions with the state probably next week.
Is it a question of money?
Now what was driving for instance, tank 12 issues were technical issues in the cleaning process. And as we got into things, we found a few things that weren't quite the way we expected them. And so it took some time to go resolve those technical issues and gave us a step back. So we're looking at probably 7 to 12 months, depending on some of the assumptions you make schedule-wise.
I don't understand. Is it a question of how clean, or is it a question of being able to close it? The article seemed to suggest that you didn't want to close it.
No, we're proceeding on now with, I mean, you know, we have described before and schedule-wise, there are many steps to get there. We are proceeding with the physical side of things, preparing for the closure of the tank.
You're going to close it.
We're definitely going to close tank 16 and tank 12. It's simply that because of the issues we faced, and these were really technical issues that we're now over, but we had faced a year or so ago, that we just had a delay in the schedule, and that's what we're addressing now, trying to get that agreed to extension date to resolve, now that we're past that point.
So it's a
We have a
possible
clear
fine.
path.
So you're trying to get around the fine.
Well, there will be penalties associated with missing those dates, so that's what we're trying to work through and extend that.
Okay, Marilyn, and then we have to close.
CAB. Over the years I've been on the CAB, we've seen these sampling techniques. Can you then, though, tell me how how is the sample actually processed? Where does it go to be processed? How's that transfer to where it can actually be read take place?
Okay. So when I pull it out of the tank, how does it get to the, okay.
Yeah.
When the basket that you're seeing here, whenever the samples are pulled, they're in a basket that's similar to this.
Okay.
There is actually a string, for lack of a better term, tied to that.
Okay.
This basket is then reeled up out of the tank. Where it comes up out of the tank, we have done a lot of shielding to protect the workers. There's a lot, they're in PPE. We use shielding for the beta. There's a lot of precautions used that when these samples come above the tank to control the exposure to the worker. So when it comes up out of the tank, it comes up into what a glove bag is. Are you familiar with the term glove bag? Okay. It comes up into that glove bag. Then the workers on the top of the tank will take these long reach tools and they will move it over to what's called a sleeve out port. It's a way of getting things out of the glove bag. So it goes into that sleeve out port, and that sleeve out port directs it down into where we have a plastic PVC, thick plastic container. These guys told me to bring one, and I said we probably won't need it, but it's a thick plastic container. Should have listened to them, you're right. It's dropped down into that thick plastic container. That plastic container is capped, again, with long reach tools. Then that sleeve out port is cut out, bagged up. Then that container, after it's all bagged up, is actually lifted up out of the hut that the workers are in, and it's taken over into a shielded cask. And this is we call it the 8-ton cask. I don't really know if it weighs that much, but it's basically a metal box that's lead lined. It's lowered down into that box. That box is located on a trailer. When it goes, and again, it's guided into that trailer with long reach tools. The workers don't ever, once these samples are pulled, nobody touches them. So it's lowered down into that box. We put the cover on the box. Then it's shipped up to SRNL where the lab takes off. Now here I'm going to get a little fuzzy because I don't know all of SRNL's procedures, but in SRNL, the top is taken off that cask, and they have some manipulators that they pull it out with and then start retrieving the material out of the sample vial. Then it moves on through there.
This is in a big glove box, so it's in a safe area.
Yeah.
It's not out in, it's not in the
No, I know that. So how long does it take for once the sample is collected there? How long is time-wise before it gets to the lab?
Okay. When it comes up out of the tank, before it gets inside that plastic container, is a matter of less than a minute. They move it just as quick as they can. They get it in that plastic container. It's bagged up. Once it's bagged up, then it's carried or flown out. We actually use a crane to fly it out to the lead-lined box that I'm talking about.
Right.
That usually takes maybe 4 or 5 minutes to do.
Okay.
It's put inside that box, and then the lid's put on it. Now, once it's in there, it's very secure at that point. It's shielded. There's no rates, and so it can sit in that lead-lined box for a couple of days until the weather's appropriate, and maybe we're going back and pulling some more samples before it's ever shipped up to the lab.
We were watching that the other day, and I assumed that plastic box had lead in it. It has no lead in it?
Which plastic box are you talking about?
When you pull it up and you put it in that plastic container to move it over to the lead line container.
No, that's just Schedule 80 PVC. So it's,
why is it not lead line?
well, what they're predominantly getting exposed to, which causes the exposure for the tanks that we've sampled so far, is a beta. So the PVC does a lot of the shielding for the beta dose.
Thank you.
Thank you very much.
Quite a bit behind scheduling for the questions. We're now at the committee discussion time. Melon, do you have anything in particular that you'd like to go over?
There are some issues with the waste isolation pilot plant, I think, that we should be talking about, or at least raising some issues. But I think it's too short here. I think maybe we'll get it on the agenda for the board meeting. And Harold and I, when we were at our last committee, when we had the chairs meeting, we had a really detailed report about WIP and some of the reports that have been, that are being produced, and some of the implications for the other DOE sites, some of the things that are being asked of Savannah River site and other sites in terms of some of the safety things, some of the deferred maintenance and things like that. So I think maybe we could get a spot on the agenda, and I'll send you some of the stuff, the information that we've received, because I haven't had time to digest all of it. In fact, some of the reports weren't ready yet, but they're already, I mean, they've already had asked for some information from some of the DOE sites. So I'd like to hear some of that, so maybe we can do some of that.
Talking November or January?
Are
you talking November or January?
November. Or, I mean, I don't know, but I haven't talked to you.
Yeah, we'll have to talk about,
yeah,
because I don't know. November might, but maybe not, depending on what you want. But I have to do the Federal Register in like a week, so.
Okay.
So our November meeting's a little earlier because of the holiday.
Well, I'll talk with Harold too. I need to go back through the presentation. We had a very detailed presentation on WIP, and some of the things that happened there were enough of a concern that they have asked for information from other DOE sites, and part of it was maintenance, because some of the issue at WIP with the truck was related to lack of maintenance, and so there were some concerns. So
if you guys could just email me what you're interested in hearing about, and then I'll take it from there and see what we can do.
Earl, I think that at the November meeting, we might want to just give a few minutes, and by then hopefully have the response to Lee Pope's question this evening about the annulus and what's left in there.
Okay. We have recommendation 312. I make a motion that we go and close that up. I don't even have to make a motion.
no.
Close. So let's mark that off the book.
What was the motion? What was 312? What did it stand for?
It's the liquid waste treatment maximization. Recommendation 321 that we're working on. I think that we were still gonna. No, not yet. So that's still out there for a little bit, and as soon as we get the information, then we'll make a determination of how we need to work with that.
So how was it So what was how was that recommendation answered then? Tell me the details. Just briefly tell us what the, maximization, what did DOE
You know
have
what,
to
I
do?
didn't,
I think James can probably.
yeah, I was getting ready to
Okay.
say, I didn't even bring that.
Okay.
What we have here, the DOE review the available technologies for liquid waste treatment and any feasible technologies improvements and determine the optimal way to allocate resources to reduce risk most rapidly till the SWPF facility can be completed. DOE agrees with the CAB that the technology improvements have potential to facilitate the liquid salt waste processing prior to the SWPF operations, and if successful, may leverage future SWPF operations as well. As briefed to the CAB, and last August during 2013, activities were performed to allow radioactive demonstration of the next generation solvent in the modular caustic side solvent extraction unit, MCU, process during early 2014. DOE would appreciate the opportunity to brief the CAB on the results of this demonstration in early summer projected for June 2014 timeframe. Number 2, DOE report to the CAB by January 2014 on their findings if an approach is determined to be available that can prioritize resources to reduce risk more rapidly. The liquid waste system plan is the method used to document planned approaches to liquid waste processing. DOE would appreciate the opportunity to brief the CAB Revision 19 Liquid Waste System Plan in April, May 2014 timeframe in lieu of the January 2014. The 2014 demonstration of the next generation solvent in the MCU will complete after publication of the Liquid Waste System Plan, Revision 19. The results of the demonstration, if successful, will inform possible future approaches to apply the next generation solvent for optimized and accelerated risk reduction via salt processing. DOE plans to keep the CAB informed of the technology evaluation and system plan changes that they evolve, and greatly appreciate the interest and support of the CAB for this area. And that's signed, who? I don't remember. Dr. Moody.
So we had the Rev 19 and then the salt stuff. That was what we had last month.
Correct.
Okay.
Yep. Any other?
The status of the outlet?
Yes.
Open now. You want to leave it open for 312? Is that what you're saying? Or you want to
Close
close
it. Unless Nina says something.
I do think that at the meeting, if you say it's closed, you should say we are closing it because,
Yeah,
that those things were said. I think that would be helpful. Okay.
okay, we take note of that.
Yeah.
And
Okay.
All right.
any other discussion before we go into the public commenting section? Yes, sir.
I'm Lee Foley, and last time I attended one of y'all's meetings, I fussed grossly about the optics, the visibility, and you've done a whole lot to starting up these things to help that. But the people that were showing the spotlight up there, I can't even see it up there, but it weren't on the side screen. So I think there's still some more work that needs to be done so that us guys that sit in the back of the room can understand what's going on.
Yes, sir. That's James, Ashley, and Jesslyn.
Can that be moved forward? Is there a reason that that's where that is?
The cord is very short. We
Oh.
could try to move it forward a little bit. Yeah.
if you had an iPad, the iPad has a spotter that would be on all screens. So
Yeah, well, it's just something that needed, when they were talking today, I could see that they were trying to spot up there, but it was useless to look over here, and I can't, that screen is useless up there, for sitting back here. Can you see it? Maybe it's just old guy.
I can.
Okay. Too much light from above. But I did want to say that I think what you've done has been very helpful. It's the right step in the right direction. Just need to take a couple more steps.
Yes, sir. Thank you. Yes, sir. Mr. O'Connor?
Joe Ricardo, Paulwood. Just a couple of comments on Steve's presentation on the dry storage for cancer. He did a great job, I know you agree on that, but that's a project that's relatively simple compared to a lot of the stuff they've done at the site. And it probably, can be done just as he said. But there's two things you're going to want to watch. One is the money. They're going to get the money. DOE needs the money for it. And the other is just of the project itself as it goes along. But if you remember one of his charts, he showed that this thing's going to get finished at the same time they run out of storage space. And they're dead on. I mean, 2019, whatever it was. Now, the system plan, 19, when you see on that, I don't think DWPF was on the critical path on that, Jim, this issue, but pretty doggone close to it. So the bottom line, if you shut DWPF down, it's going to reverberate all the way back through the plant. It's going to affect the tank closures. It's going to affect everything, that's on that critical path. In other words, meaning the SFA tank closure schedule. The other thing is every year you push that schedule back. It's $500 million cost that's going on. So it's real important that you watch that above ground storage thing as it goes along and do whatever you can do to help DOE keep it on schedule, because it'll have real negative impacts as the schedule slips.
Thank you. Yes, sir.
Bill Wallace is my name. I've been very disappointed in what the board has done recently, especially the recommendation on transmutation. I fought that one as hard as I could. It's a silly motion. The board went ahead and passed it anyway. And the thing, I guess, that aggravates me more than anything is that it's the second time that this motion has come before the board. It came before the board a year ago, and the board passed it then too. I think that if, I agree with Joe that the discussion on the pad, the new storage pad is really good. That's something that the board should get behind. They should push hard to get this stuff to whip the transuranics that we've already sent, or some of the transuranics we've already sent to WIP are much more radioactive than some of the vitrified high-level waste. So it makes sense to me that we can send these vitrified high-level waste canisters. It's something that the board needs to get behind. It's not going to be an easy lift, but it's a lot better than some of the silly things that the board is engaged in. I know you all have done these things with a good heart, but you haven't listened to the people who can help you with these motions. And I think hard-headedness on something as complex as these issues just doesn't stand the public in good stead. I'm getting disheartened with the board to the point that I'm thinking that it's time to recommend that the board be shut down. So that's my comment.
Thank you. Anybody else?
You done?
Oh, I'm done. Thank you. Thank you all for coming.
The next meeting will be at 6:30. I had to do it last time, so.
I'm gonna move fast here so that we can have Alan up to give us H Canyon update. First of all, welcome everybody. Thank you for coming. And remember that the gizmo is listening and looking. So if you get up to speak, could you go to the podium so that you get a good picture taken? I'm also supposed to remind you that we should keep to the topic. And finally, that there will be a public comment period. Encourage everybody to comment and again be at the podium. We have, I'm going to skip all that, James, and just go right to the open recommendations. Thank you. We have 3 recommendations that are open. 307, 319, and 320, and at least 307 and 319 are fairly dated. 307, the subject is transferring materials in L basin to auxiliary dry cast system. Was recommended by this committee and put before the board and adopted in July of 2013. And we did get a response from Dr. Moody. As I said earlier, it's sort of a paper stonewall, which simply says that they accepted some of it, but that there had been a study that determined that that the dry storage would cost about $500 billion more than if we ran it through H Canyon. So the decision was to eventually run it through H Canyon, and we don't know when that will be. Also, they said we don't accept part 2, which asked that there be a conceptual strategy evaluated for the best options to bring dry storage capability to L Basin, and that was rejected on the grounds that there was additional research needed to determine what I guess all the variables involved for drying the aluminum cladded fuel. And we never got an exact definition of what that means. And finally, in subpart 3, it was rejected. That was a recommendation that would perhaps DOE might want to utilize an option that had been utilized over many decades before, that is to ask NAS or some other outside external resource for ideas and guidance on these issues. And they rejected that, saying that it would be premature because we haven't conducted the drying of aluminum cladded fuel study. 319 was, the subject was planning for disposition of SRS canisters and L basin materials. And again, it just essentially said that we need to have a plan that involves storage and transportation and containerization, that there should be some studies done to that effect. The department, from over Dr. Moody's signature, said they cannot adopt our recommendation because it's premature to develop a plan for a facility that's not been identified, that is the 2048 Deep Geologic Repository, nor had any technical design work completed. And furthermore, it reminds CAB once again that CAB is not responsible, or environmental management is not responsible for interim or final repositories for HLW or SNF, and therefore it's, I guess, out of our purview. 320, the subject was chemical separation, we've heard about that tonight, or partitioning and transmutation, and what we are recommending is that that be supplemental to design plans for deep geologic repository, and as much as it might possibly reduce volume, radioactivity levels, and half-life of the fuel, therefore being very cost-effective because it would reduce what it was we had to store and how long we had to store it. And again, we were told that that is out of our purview, although they will pass along our suggestions to nuclear energy, which now has responsibility for the ultimate decision on where and when we will have a repository. All right.
Is that a change in DOE's plan policy? Is that a new group in DOE?
I don't know when it happened. We were told about it about, I don't know, a few months back.
It's Pat McQuarrie with DOE. Yeah, with the Blue River Commission was established, and then the department responded to that with a strategy for disposition of spent nuclear fuel and spent high-level waste. The Office of Nuclear Energy picked up responsibility for the final repository, and you may recall, and don't quote me on these dates, that a pilot location will be available by 2021. Places be able to start shipping to that pilot location by 2025, and then the final repository should be available by 2048. And the Office of Nuclear Energy has a responsibility for a consent-based approach. They came down probably a year or so ago and briefed the CAB on their starting points, and they were just getting kicked off because the Blue Ribbon Commission just finished its report, and the department just issued its strategy on final storage. So I think at the full CAB meeting, we talked about maybe revising the work plan for, or including in the work plan for next year, having Office of Nuclear Energy come down again, brief the CAB what has happened over the last year, year and a half. So it's not a new group. Office of Nuclear Energy has been around for quite a while. The old group, RW, Office of Radioactive Waste Management, used to have responsibility for the old Yucca Mountain, but when Yucca Mountain came off the table, they disbanded that office, and so Office of Nuclear Energy is now responsible for the repository or some form of wherever waste will go in the future.
Are you saying that the CAB cannot give recommendations relative to permanent disposal to DOE?
You can give us recommendations, but we can't. We are not responsible for that final disposition. So
but
we'll
the
do
fact
like
you're not responsible means that you have the responsibility of getting it to the responsible people.
And that's what we are doing. We are providing every recommendation you provide to us. We provide to the Office of Nuclear Energy, and that's why it may be beneficial, Rose. I think you talked about before. See what are they doing with some of this information we're forwarding to them. So again, it's your work plan when you develop that in January, February. You may consider doing that. Again, you have many things on your plate, and so, but that is an option. So answer your question, Lee. Office has been there for a while. They've taken over the RW.
But the point is, DOE shouldn't refuse to accept the response, the recommendation, because it's not in your purview.
Well, we are only refusing to provide you an answer because we can't answer that. We're not,
I understand.
Yeah, so we are providing all that information to the Office of Nuclear Energy.
Pat, I share Lee's confusion. Maybe the first 4 years I was on this board, we always had a little black box down there that started with Yucca Mountain, and that went away, and then it had National Repository, and then that went away, and we went through several iterations, and finally the black box went away, and some writing came up over here with some nebulous description of where all this stuff was going, if not when.
Now Rose, I'm not familiar with this recommendation at all. But, if it's something that the CAB believes to be very important, you ought to go back to them and tell them you don't accept their response.
Well, that's why we've left it open.
Yeah.
We've left it open because we don't accept it.
Okay.
And.
Do they know that? I mean, is there a clear statement to that effect?
Yeah.
Okay.
Yeah, if it's left open, it means we want more information or we don't agree with what we were told or what, we're not closing it, yeah. But the other issue is that in addition to some undefined point at which we no longer were allowed to recommend what was supposed to be the ultimate disposition.
Well, that's the reason to deal with it.
But what it also does, which I think the CAB needs to address in language, is the language now suggests that the CAB is only responsible for suggestions or recommendations, containerize and store materials here at SRS.
Don't get yourself in that position. That's not the
That's
intent.
what the language says now.
That's not the intent of the CAB nor the bylaws that were originally put together.
So we have had responses that said NE now has responsibility, it's outside the purview. At one time, there was a response that said it would be transmitted to NE, but the rest of the time it doesn't say that. It simply tells us beyond our purview.
I was trying to understand what the comments you were making were.
Well, DOE has said they're going to take the recommendations and send them to NE. And that's about all EM can do.
Oh, absolutely. I agree with that.
And then also, DOE said that they would ask NE if they don't want to have input down, and if NE chooses to do so, they'll comment on what's up. They may choose to say no.
But Joe, that's only been on one occasion. On one occasion, and one specific recommendation where we told that it would be passed on to NE. The rest of them is simply told that EM no longer has responsibility and therefore it's beyond our purview.
But any of the ones involving the repository have been forwarded on to NE.
That's good to know.
Hanner, who came down, has been forwarded to him and to his boss.
That's good to know. James, can you move through these for me, please? I have one up.
Oh, you want to get it backwards?
Yeah, there. The history. And number 8, CAB's not involved with National Repository design, planning, and readiness now. That the language that we have received in Dr. Moody's responses, in fact, is what this has resulted in. And so if they are transmitting that's good to know. We do not, however, have it in writing anywhere, and that would be nice.
Rose, this is the CAB was told. This is what they told you, but DOE-SR told you.
I think this is Maxine, I said DOE. I think there's a misunderstanding on number 8. When the responses come back on the repository, it's talking about DOE-EM's responsibility, not the CAB's responsibility. So I think there's a misunderstanding in number 8 and in the responses that you're getting from the department. EM has no purview over the National Repository. That's what most of those recommendations say.
Okay, I'm happy to have that clarified because the language didn't indicate that that was the case. There was confusion. All right, having passed along the information available to us on these recommendations and the fact that we're going to continue to leave them open. I have only one other comment. Our chair asked that the graphite, German graphite material be included in a discussion this evening, and I am told that at the next full board meeting, Maxine Maxstad will be giving us an update on that. So that's on in your work. Yeah. So we will get an update on that at the next full board meeting. Yeah. Other than that, does the committee have any comments or questions about these?
I have one question. When in Dr. Moody's update, he talked about the processing of the nuclear material that had been stored in elevations that were at risk. I don't know how. I mean, it was a significant accomplishment, and it was wonderful. But he also, and then in the write-up or in the news release from the site, it talks about additional highly enriched uranium being processed through H Canyon. What is that?
That's the A-Rod, the materials, the 1,000 bundles that we got approval to process.
Oh, from Australia?
No.
We're gonna cover that. You're gonna cover it in the presentation. You're gonna hear all about that tonight.
Okay.
And there was a difference between the campaign we completed. We couldn't recover any of that uranium because it had thorium along with it.
Oh, okay.
The fuel that's already started processing now that Alan's going to talk about, we can recover that uranium.
Okay. All right. And that was always on the books, but the processing of it was always an issue. It had been an issue till now.
It got approved in March of 2013.
Okay.
What I understood you to say is that you couldn't process through H Canyon, the thorium, because
Let Alan do his presentation.
Okay, all right, I will have it all.
I'll ask you.
Yeah, you can ask me.
Are there any other comments or questions?
No.
Then let us hear from Alan Gunther, who's going to give us an update on all of this. He's going to clarify everything.
How about that one now? Really, they're going a little bit too far.
Remember, I can't see that.
From the chair, there's a chair up front there.
Come on up here, ladies.
Right there.
Put it on here.
It's on there.
Okay, go ahead.
Can you see that all right?
Yeah, I can see
Can you
that.
that one?
Let's sit up here. If he uses the pointer on that front screen, you
Oh.
can see it.
Why don't you come up here? Banana.
All right, I will.
Right up there, front seat. Yeah, we got plenty of room.
Anybody else can come?
You ask.
Come on up.
It was Alan doing it.
I can give you some. You don't have any problem hearing me, like, no, good afternoon. My name is Alan Gunner. I'm the Senior Technical Advisor to the Assistant Manager for Nuclear Material Stabilization. I'm getting on what H Canyon's been doing in the past roughly year, and it's been a very busy year for us. Purpose of this, of course, is giving you an update on where we are on H area operations. Some of those include plutonium processing for NNSA, plutonium disposition program, the sodium experiment reactor material, which is the material they were talking about, the vulnerable fuel that we'll be talking about, and then the highly enriched uranium spent nuclear fuel that we're beginning to disposition now. And one other one that I've added is a little bit on the Canadian liquids, because that keeps coming up and people keep asking questions and all.
Alan,
Yes, ma'am.
the sodium, the SRE, that is the thorium, right, from
Correct.
Moore Park, California.
Yes, correct. I'll skip the acronyms. Again, as most of you are aware, H Canyon kind of sits somewhat in the middle. Excuse me. Receives material from K area, L area, processes them. The waste would go to the liquid waste system, the DWPF. Depending on the material, some of it goes then to TBA, down blended. Uranium will go to TBA. Again, this has been a very busy year for H area. And I'll go through each one of these as the sub-bullet. This is kind of what I'm going to talk about. One, we resolved a ground level release issue that dealt with a potential inadequacy in our safety basis for the facilities. I'll kind of describe that. We did get started up on producing plutonium oxide and HB line. Been a long, hard road there. We completed the sodium reactor experiment fuel, that dissolution, and we've actually began dispositioning that to the liquid waste tank system, and we've initiated the spent fuel processing. As you're well aware, H Canyon has a safety class
So that's the 1,000?
Yes, ma'am. The other spent nuclear fuel is the material that the supplement analysis and amended record of decision that was signed on March 29, 2013, allows us to process 1,000 bundles of spent nuclear fuel, what we call MTR type fuel, plus an additional 200 cores of hyper fuel that's coming in out of Oak Ridge, where they do the high flux reactor up there at Oak Ridge.
We're getting 200 more?
We have 120 on site, and I'll talk about that, and we could potentially get up to 80 during the time period that we're processing. Talking about the ground level release, we have a safety class ventilation that we heavily rely on in each area to ensure we filter all the air coming through so that we do not have any radioactive release. However, when we got to looking at it, we knew that we found out that potentially the stack liner, we have a 200-foot stack and it's lined with ceramic brick. In a seismic event, the potential exists that over the years, the degradation has caused where those bricks are weakening, and you could actually have a collapse of the interior of the stack, not the stack itself, it's the liner, and you would get a pluggage. Well, when you get a pluggage on one end, and you got air coming in from the other, from the fans that are running because they are seismically qualified and have emergency diesel, you get a pressurization. What we identified is we had areas in the ventilation system that during that pressurization, you could actually have a release that comes out at ground level, which is not good, especially if you're one of the workers in that area and you're responding to an event. You would have to deal with it. So what we did is we identified some of the modifications that were needed to preclude that release. And again, we have an annulus floor. We had to seal around that to ensure we could not get a release. Sealing of the exhaust tunnel between the canyon exhaust fans and the stack, there were some openings in there. Closing a support system tunnel. Modifications of the central exhaust. What that is, the central exhaust doesn't go through the fan filter. It's your personnel area. So there was a potential that you could get unfiltered air going in through there and out the stack. So, excuse me, if you pressurized it, then you could force it into an area that was unfiltered.
Isn't that what happened at WIP?
Somewhat. Yes. So what we've done is we've sealed that area so that you can't get that pressurization back through the central exhaust. The other one we identified was the old sand filter. We have two sand filters. One was originally built in the 1950s with the canyon. In the 70s, we had to build a second one because we were starting to see some collapses inside of the laterals that distribute the air. So we built a new one. We have now isolated the old sand filter. We do not use it. All the air goes through the new one so that we ensure we have a filtration going through. We revised the technical safety documentation and the technical safety requirements to reflect all of these upgrades. This was a huge upgrade. I mean, this was a huge undertaking. It took us about 3 months to complete this, and it was done. In fact, that somewhat delayed some of the processing of the SRE, is that we were tied up with this and the plutonium processing. So it was something that once we identified it, we did it all over this summer. Yes, ma'am.
I'm glad you identified it. And I guess my question is, how did that come about? Was this because of a WIP or?
No.
Revision? Or?
No, actually, we did a revision to the safety basis, the documented safety analysis, and in some of those, they started looking at. We knew in the past that we had a potential for that stack liner to collapse. One of the options in the past several years was actually to throw open the doors, that would allow the air to come out at that point because it was already coming out after the sand filter. What we identified was areas that you could get in leakage and bypass the sand filter, which would then create a release that was not acceptable. So it was during some of those reviews and upgrading of the safety documents that this information was identified.
Alan, why did the National Nuclear Safety Board never address this in all this time?
I mean, the Defense Nuclear Facility Safety Board?
The nuclear, yeah.
we have, you know, again, we've looked at our ventilation. It's a safety class system, and we were sure they were aware of the stack liner issue. But again, it was back when we started doing all these revisions and digging deeper, going back into some of the 1970s documents and all of what was done back then, that, you know, you get more information, new information, and that's what came out. I mean, it wasn't a matter that the safety board didn't do their job. This was information that was uncovered, you know, as we were going through and updating to the 3009 DSA.
Well, when they come on site, do they look at the safety analysis information that's available, or do they do hands-on inspection?
Yes and yes. I mean, they do look at our safety basis. They usually, I know with the HP line, they actually reviewed the draft to validate whether they found it acceptable. Also do walk downs. I mean, we have 2 site reps that are constantly out in the facilities, walking around, looking, seeing what's going on. The board sends down teams at times, depending on different things that they are got interest in maintenance or safety documents, fire protection, you know, pick a topic, and they'll send down a team that walks around buildings and looks at those specific areas that they're evaluating.
Yes, just to build on what Alan said, good questioning attitude by the system engineers for the contractors that identified this. As Alan said, we've known about the potential of this accident, but how far back do you keep questioning, this may fail, this may fail? So great questioning attitude by the system engineer. And then regarding the Defense Nuclear Facility Safety Board, as Alan said, we keep them aware. And so they were very pleased with what we were doing, the progress we were making, the extent of the review, that's very elaborate modifications. And if they're satisfied with what the site is doing, both DOE and our contractors, there's no need to write a recommendation or report or anything. They continue to monitor what we're doing. So no surprise that we didn't get any, you know, formal report from the Defense Nuclear Facility Safety Board. So that's not a surprise.
All right, so we've completed those. To kind of give you an idea, this is the schematic. Again, air comes through here. We have the sample, the exhaust tunnels, and then out the stack. The red area is where we were talking the brick liner that over the years, it's acid resistant, but after 50, 60 years of moving up through that system, you get a degradation, you know, of the cement, the binder, and all that stuff. That's what was identified as failing. And you can see all these little red dots, and that doesn't tell you exactly, but those are the areas that we identified had to be modifications made to those systems to block the, you know, any escape or leakage that would come out during a floodage. Some of them were replacing, you know, fire doors with doors that actually had very good seals. In the past, they were, you know, they were there, but they didn't seal very well or anything like that. That's some of the ones that were over in this area.
Alan, is there indication of failure on the line?
No, it's not a failure now. It's a failure that potentially, you know,
I understand,
you know, the
but is any indication of corrosion or degradation?
We've seen, now, we know there's some degradation over the years from the acid attack, but we don't see an imminent failure. But in the event of a seismic and you start shake, rattle, and rolling, I mean, you know, it can potentially fail. All right.
Where does the air go if you get the collapse?
Now?
After modifications, I mean, some of the red stuff, you've made the fix that you got on there. So now the stack, you had the earthquake, the stack's partially falling, your fixes are in place. Where's the air released?
I think it's still partially going to go up the stack.
Most of it's still going up the stack.
So we'll monitor the exhaust to make sure that the amount of flow is restricted, but that's where it's going to go. It will be filtered and elevated.
Remember when you first start, assuming, you know, we're at normal operations, you got 3 fans running. So when it first collapse, you know, when you first get the seismic, you get collapsed, you're going to have a big pressure going against it. Once we get after the seismic, we'll drop down to probably a 1-fan configuration to ensure we got negative, but we won't process, but it'll be at a much lower rate, which, like the Pat said, then it can still get up through the
rubble.
Before you made your fixes, you built up so much pressure that it leaked out.
Yeah, so quickly, I mean, when it first happened, it dropped down. All right. Processing plutonium for the mixed oxide fuel fabrication facility. In 2011, the National Nuclear Security Administration decided to use H area to produce plutonium oxide. Basically, it's plutonium that's already stored in K area that's being processed, purified, converted to an oxide. We are using H Canyon to dissolve the material. HB line is the facility that we restarted to use the oxide production line. We're reconfiguring the process to allow a ramp up to a full metric ton of plutonium production rate. That's scheduled more like out in 17 time frame that they're having to hire staff. Again, we went through, developed the required safety basis documentation, any modifications. Again, we did the 3009. This is the DOE standard. It's the new standard for report. It gives you the new format, the details. We put a 3009 compliant documented safety analysis and the technical safety requirements for HB line.
Alan?
Yes, ma'am.
The mission to produce plutonium oxide for its surplus and disposition program.
Yes, ma'am.
The disposition program, could we?
That's MOX right now. That is the big plutonium disposition program. And as far, people I know question, why are we doing this if MOX is dying? First of all, MOX is not dead. Congress is still funding it. I mean, that's not my decision, but Congress today is still funding that MOX project to be constructed. We've got to, continue on. The other part, just to let you know, that disposition options, if MOX were not to go forward, requires an oxide material also. So, this system here is preparing plutonium that would either be suitable for MOX or you could disposition it in other alternatives if the department, again, today, right now, the department is still on the course to send the plutonium to MOX. That is
once it's processed as MOX appropriate, would it have to be reprocessed to be appropriate for some other use?
No, it is then fully set up to go through, depends on which disposition, vitrification, disposal of WIP.
But are there any real plans for that to happen? Suppose MOX doesn't go forward. This is in process into MOXable fuel. We now can use it for A, B, C, or D. But are there any plans?
We have looked at alternatives. But again, I want to go back, and again, I've got to be careful because this is really an NNSA program. It's not EM. There's been options looked at, but as long as the DOE or the Congress and all is saying MOX is the route that they are wanting the disposition, the department is not going to go spend, one, we're not authorized because we don't have the money appropriated for that purpose. The department has identified in those options, again, we've looked at vitrification. In fact, EM at one time was going to build a plutonium vitrification facility in K. We've looked at, we already down blended material that we sent out to WIP. We've looked at the ceramic canning canister concept back during the immobilization project. So there's been numerous alternatives that we know are out there. Are we pursuing them at this time? The answer is no, because today, Congress keeps giving us the position they want to go forward with MOX. They are funding that site.
And just a clarification, the oxide we're producing is not in fuel form. It's still in raw oxide powder. So it's not actually that's what MOX will do, is convert it into a fuel element, a fuel rod. So this, when we get done with it, it's just raw oxide material. And it's that one, say you wanted to ship it to WIP. You don't have to, you just mix it with that inert material and you package it up. So it's grows it. I thought maybe you misunderstood. We were actually,
I did.
Okay, so it's actually the raw.
Yeah, this is the feed material. This is feed material for MOX. Yes, ma'am.
Marilyn Parsons, CAB. So in safety and national security is the oxide, is the plutonium oxide in a form that is better to have on the site? I mean, is it more dangerous? Is it more of interest to, you know?
It's actually, from a security standpoint, it's probably a step down from where it is today. You know, not a step down in target.
Okay.
It would not be as desirable.
Okay.
Want to make sure that, excuse me, I didn't mean we step down into, perspective, they're equal. They're stored in K areas. So K area's got its security around it, it's got all the guns and guards and everything else. It's stored in it'll be stored in as we produce it, put back into a 9975 shipping container, which is a type B shipping container that has double containment, leak tested before, it's leak tested afterwards. So you got, like I said, dual containment, and it's inside a 55-gallon drum with cane fiber board that protects it, gives it some thermal protection. It also gives it puncture resistance, you know, that if somehow you ran into it with a forklift or anything else. My assessment, it would be equal to, you know, what's in K area now. We're converting it to an oxide. The oxide, that's just, and like I said, it's just as secure because it's in the same building as the other material. But if you were looking at it from an outside group that was wanting to do something, you wouldn't take that as your first choice if there's other types.
So the decision to go ahead with this part of the program is because the assumption is that the MOX program will proceed as originally conceived. Somebody in Washington that's seen it on Groves, and there are no customers for the.
Kind of a dual thing, Rose. One, the answer is yes. We're still headed down the MOX pathway. So this makes material in a form that's suitable to feed the MOX facility. The second part that goes with that is we're still doing it, you know, today because, again, it's putting it in a form that will allow ultimate disposition anyway. If you chose another alternative path, then the material is now in an oxide form that's suitable. Like I said, let's use plutonium vitrification. We were looking at that previous EM one.
Yeah.
You feed plutonium oxide into a borosilicate glass and small melter, not into the DWPF melter and small melters. Again, you got to have an oxide feed as feed. So this makes an oxide feed that you can then feed there. It's like Pat said, if you're going to WISP, and down blend it to go send it to WISP. WISP can't take anything but oxide because they can't take anything reactive, they can't take anything combustible or anything of that. So what this does is it moves the material into a form that has many more disposition options than what it is in its current form.
And the original plan to either vitrify or go to MOX, and then the decision, of course, was MOX based on negotiations with Russia. But under the original plan, we were going to vitrify 50 tons. Is this that difference between the 34 that we agreed to do with Russia and 50,000?
Well, there were a total of 50 tons of plutonium that's going to be dispositioned. 34 was going to MOX. 16, if I'm doing my math real quick. 16, 17, that was, I think actually the number was 51, wasn't it, Jeff? With 51 tons, 34 to MOX, 17 that would have went to the plutonium immobilization facility at the time. There was some material called zipper that was pulled out. There's 4 tons of plutonium. The Office of Nuclear Energy, again, pulled that out, said we may have a programmatic need for that, so that came out. There were some others that were pulled out. So what you've ended up now at Savannah River, we have about 5 tons roughly of material that's not suitable for MOX that we're dispositioning EM in. EM's got that responsibility. Then there's roughly 7.8 once you complete consolidation that will go to MOX. This is part of the 7.8 that would go to MOX.
Part.
This material that we're processing here.
Yeah. And where's the other? Is it on site?
Some of it is. We haven't finished consolidation. Some of it is, and that's what, remember we started dispositioning plutonium to WISP. We were EM with down blending material with an inert agent. for less than 10%, packaging in Pico pack containers. We shipped out roughly 400 and something containers to WIF. Most of them got down into the mine prior to the incident. There's still some out there that's sitting above it, but you know, we're starting to the EM is starting to disposition that material. And if you remember when I was down at Beaufort, and I think Jay talked to y'all before, beginning next July, August, K area will resume that downblending program that was being done in H area. So we're going to start preparing plutonium to send it to WIP, the material that's not moxable due to impurities, due to isotopics. There's various reasons why plutonium can't go into the MOX program. EM has it in their inventory. So EM is starting to prepare the material that will allow it to be dispositioned and exit the state of South Carolina once WIP comes back up.
But in order for it to get to that point, it has to be processed, the pits have to be processed. And we don't have the facility now for processing the pits.
Okay, now you're getting to a bigger group. Okay, at Savannah River, I have two groups of material. I have no pits. I want to make sure everybody knows Savannah River has 0 pits stored at its site. What we have is the non-pit plutonium. That plutonium is basically split into 2 groups: moxable, non-moxable. Now, EM owns it all because it sits in K area. I mean, it's just, that's how it is. NNSA has said we'll take 7.8 tons of the good material that would allow us to meet the MOX specs. We will send that through the MOX as part of the 34 tons. Then there's a separate group of about 5 metric tons sitting over here that EM owns that won't go to MOX, like I said, due to chemical, isotopic, whatever. EM is starting to go ahead and prepare their material to go to WIP so that we can, you know, have an exit strategy for that material out of the state of South Carolina.
And you make the point of material going through H Canyon.
What? Go ahead.
If it goes through H Canyon, through solvent extraction, it's then moxable, is it not?
Okay, yes.
Yeah, okay.
We aren't going actually through the solvent extraction, though, just to let you know, we're using the anion columns up in HB line.
Just use HB line?
But it's still, the oxide we're producing is meeting specs when we produce it. We know that. We've already made some. We've analyzed it. But again.
But all the discussion about non-moxable.
But if it's isotopically unsuitable for MOX, H Canyon can't correct an isotopic issue.
No, they can't do anything about it. None of the canyon or.
Right. And then there's some that's just got such a high chloride that I really don't want to put a lot of chlorides down in the canyon either, because chloride, heat, and stainless steel don't go well either.
They don't do good with iron strand either.
Yeah, right. So, but that's kind of where we are on this. And
but will the pits come into K area? I mean, I understand that the pit, tear down the pit building has been completed. It's just been put in cold standby.
No.
It's not completed?
Never was built. They're not even been started. That's what they call the PDC, pit disassembly and conversion.
Disassembly.
Okay. That one was never built.
When the pits come in, then are they going to K area?
Right now, the thought process is more, they will probably be dealt with at Los Alamos. That's the thought process. That's not been decided. If we bring them in Savannah River, we're going to have to build a conversion facility, PDC. That's expensive. Nobody wants to build this. But yeah, I mean, whether they use K for storage or it has its own storage, that'll be wait to be decided. But today, right now, there are no plans to bring pits onto Savannah River at this time. They're out at Pantex or out in the west, and that's where they're saying the only thing we have is a non-pit plutonium here at Savannah River.
And all the pits are in NSA. So again, there's not.
I understand that, Pat, but there's a kind of a cognitive dissonance here. We have a little bit of moxable plutonium that we're going to process, but at the same time, they're building the MOX facility.
Yes.
Maybe. And when that MOX facility, that very expensive MOX facility is finally completed, it needs to ramp up right then and right there to be cost effective. But we have no facility to tear down the pit point.
Again, that's NNSA outside the CAB purview. But, okay, so I understand from a taxpayer, you say, I built MOX, where am I going to get the feed material for it? I understand that's a big concern, okay? It's outside the scope of EM's CAB board, okay? We're going to feed part of this MOX to disposition material, but the pits or what else feeds it, will, just like we transfer information on the repository, we can still have NNSA come and talk about their program periodically. But again, to get into the details of pits and everything else, way outside the scope of Alan's presentation.
This is partially, you're talking about MOX. This is why this is being done, so that it will have early feed. And that was the reason this decision was made to even do this, was to ensure MOX had the early feed when it comes up.
So how long do you think MOX can run on this particular bit of oxide?
The throughput stated design throughput of MOX was 3.3 tons a year. Now, we all know you're not going to start up and be at 3.3 tons. I don't know their ramp up rates, Rose. All I can tell you is this would, Savannah River would be in a position to provide to NNSA or EM with the 7.8 tons. Depending on its ramp up rate, you know, that could vary in length of time.
This plant has holes in it.
Processing, doing that, maybe 2 years of processing per month.
You're running full speed to begin with. But
Yeah, 2 or more. Yeah.
Rose, is your question really, if it's come to Savannah River, you want to be sure that if that's someplace to go, they're not going to sit in Savannah River. Savannah River will be able to do something with the tips to feed it to want.
Well, that's only part of my question. I'm trying to get in my head here some sort of outline of a plan, a smooth plan that sees all of these materials going into that facility that some people say will be built and some people won't be built. And then there's the question of, well, even if all this stuff goes through, who's going to use it? So far, there are no customers, and it's at SRS.
I understand.
All right, let's move on.
All right, just to give you a flow sheet, just quickly, this is the process that we use for H area. Again, plutonium comes in from K area. It's in a solid form. And again, it's stored in a 9975 in K area. We bring into HB line phase 3, and again, HB line was built in various phases. We're using one part of the facility for this. We will unload the 9975, take out the 3013, open the 3013s up because they're in stainless steel. You know, 3013s are stainless steel, not compatible with HKN process. So we repack them into a carbon steel can. That carbon steel can is then transferred to HKN. It's placed into the dissolver. We dissolve it using a nitric acid process that we've used all along, boiling nitric. Once dissolved, it's transferred to a product tank where we hold it. Then once you're ready for HB lines, then that material is transferred up. It'll go through the anion exchange columns where it's purified and concentrated. It then gets fed to the precipitators where we mix plutonium nitric acid with oxalic acid. You grow crystals of plutonium, basically plutonium oxalate. You allow them to grow, and then you filter them, and you end up with a solid. You dry those. You put it in a furnace. We take the furnace up to about 600 degrees centigrade. You change it from plutonium oxalate to a plutonium oxide. It's then dumped, put into a product can. That can is put back into a 9975 that has been refurbished to meet the current, days, because after it sits for years, we need to put new O-rings where the O-rings are and things of this. It's product speed here where it will be stored with the other material until awaiting MOX coming up online. All right. Again, where are we today? We've completed multiple safety-based changes and procedure changes, training. We went through a readiness assessment. We canyon's been dissolving the non-pit plutonium in preparation to feed HV lines. We've implemented all the new DSAs. Again, we completed the readiness assessment. And on August the 8th, we introduced plutonium solution to HV lines. And on August 27th, we made our first can of oxide. We will hopefully be going a lot faster. We were going very deliberate on the first process. Again, this is your ramp up. You're not going to jump up and be running at your full speed. But we have it to date made 3 cans of oxide. So we're starting to move on, and a lot of that's getting the analysis. We wanted to see what the analysis, see how well we were doing with the purification and everything. And everything is very well. Right? We're the product coming off HV line is excellent product. Actually better than we thought it would be as far as chemical purities. Vulnerable spent fuel. This is we completed the dissolution of the sodium reactor experiment fuel on August the 14th. This is material, this was, like Maxine had said earlier, a thorium-based fuel. The problem with thorium is when you mix it with caustic, it becomes a sludge like peanut butter. So what we had to do to ensure that we didn't plug our waste lines up, we dissolved a lot of high aluminum, low uranium fuel to mix with it so that it would stay in a liquid form when it goes down to the liquid waste system. Right now we've been storing most of it, but we have started transferring some of it. This is not going to the standard waste system to be passed around. This is a sludge batch tank, which will then feed directly into the DWPF. They do not want thorium into the, we have some thorium from past campaigns, but they don't want to add any more. So we're actually transferring directly from the canyon straight to the sludge batch, which will then feed directly into the DWPF process. And like I said, we have already started those transfers into this those sludge batch that they're now putting together that would then be feeding on the next feed to the DWPF when it's utilized.
And do the glass logs containing the thorium have any characteristic differences than the?
No, ma'am. It doesn't affect the characteristics of the glass at all.
So they'll be stored exactly the same way?
Stored exactly the same. It'll be mixed in with everything else. You wouldn't even know the difference between the two. Yes, ma'am.
Dawn Gillis, member of the public. What high aluminum fuel was used to dissolve? Did it come out of the basin, and how much was dissolved?
You want me to take that one?
I know it is fuel from the basin. It was some Ford reactor material and DR3, which is a German fuel.
Denmark.
It's it has some silica in there, I think. But
Total campaign, including the SRE, was 147 bundles.
Okay.
Thank you. All right. Then what you were talking about, Marilyn. We are now getting into the campaign to process highly enriched uranium fuel. The difference here is that this material is recoverable. We will downblend this uranium, send it to TBA. The material with the thorium, the uranium that was there, had a lot of uranium-233, which has a high radiation with this. TBA did not want it. DOE approved a supplemental analysis and amended ROD to allow the processing of 1,000 what we call MTR, material test reactor bundles, that are currently stored in L Basin. These are not new material to be shipped. These are coming out of the L Basin. And up to 200 high flux isotope reactor cores. Now there, I will tell you, currently L area has 120 cores stored at L Basin. We'll process all 120, and then Hyper has cores sitting up there that they've already pulled out of the reactor. They've been cooling. The only reason they haven't shipped to Savannah River is our racks are full. So as soon as we start processing the Hyper, then they'll start backfilling in, and we can process up to 200 Hyper cores.
Alan,
What had the U-233 in?
The SRE plutonium reactor with the thorium material. Not this.
Not this.
This is good material.
This is all good.
This is highly enriched U-235 material.
Now that they've decided that the dry cast system is preferable for the tank disposition program, are they going to go ahead with the expansion of L basin capacity, installing dry cast systems?
That has not been decided. As you got a letter from, one of the recommendations, we actually had an organization called MITRE, which is an independent organization out of Washington, does all kind of cost benefit. They do a lot of modeling for me at Savannah River. They actually modeled and put in the cost, and what they came up with, it says it was more cost effective to process fuel than it is to dry storage. And that wasn't even taking credit for the uranium values. What you get is such a reduction in the amount of volume that goes against Yucca Mountain. And Yucca Mountain is very expensive. I'll use Yucca Mountain because I don't know where else it would be. Right now, that's the only repository we've even identified before, but I'll just say Yucca Mountain. The volume reduction is so large that that's where the savings really comes from. So that was the Office of Management and Budget. If you can remember, back in 2013, had a very significant issue over us processing fuel. He did not think it was cost effective. So we had MITRE come in, do an analysis. Actually, it was briefed to OMB, and he actually now is not objecting. I will not say he's in agreement. I think that's pushing it a little too far, but he is not objecting to us processing this material because it was shown to be more cost effective.
So then that 1,000 that they said we could process is going to be increased?
That's an option. We will have to, again, Rose, once we get closer to finishing this, it will depend on who's in the White House, who's head of the Department of Energy, whether they favor processing, don't favor the politics that gets into all this. All we know is today, we figure we got a major victory over getting that rod approved that at least let us start processing fuel. We were ready in 2010 to start processing fuel. And then we had the door slammed in our face. So this is a major breakthrough in our opinion processing material. Again, we initiated the processing on September 16th, and it is going very well. The material will again be dissolved, the uranium be recovered, purified through the solvent extraction. Now there we will be using the Canyon solvent extraction process. That's going to be down blended to an isotopic of 4.95% enrichment, and then it will be shipped to TVA. Actually, it will be shipped out to Richland, Washington, to Areva, because they're the ones that will convert this material. They'll convert this material to fabricated into fuel for TVA. Areva does that process, so we'll be shipping it out to them.
Areva's still alive then?
Well, they're the ones at Hanford, or it's not at Hanford, but out of Richland, Washington. That's where we'll be shipping this material versus before it was going up to Irwin, Tennessee.
Barring any, significant issues, what's the current plan to complete all this material?
The original plan was completed around 2019.
Just this material, 2019?
This material. Again, you're processing this material along with plutonium, which does impact some of our waste limitations. And based on those low waste limitations, we could be extended out a couple of years due to the availability of the liquid waste system. And we're working with Gene Ridley and that group on, that system and balancing with them.
The TVA is okay with the length of the program and being able to use it at the rate we're going to provide it and all that kind of stuff?
Yeah, that was one of the reasons they went out to Richland, Washington, because they have up in Irwin, Tennessee, had a huge capacity. And so feeding them a little bit of material did not meet their needs. So they went ahead and modded their facility out at Hanford, or out at Richland, Washington, so that they can take a lot, a smaller amount of material, and it's still more cost effective for them.
Is somebody working on Plan B in case Ariba doesn't make it this time?
The answer to that I know right now for me is no. I have a contract with Ariba, a signed contract that says they'll take this material.
With TVA.
For TVA. Actually, we have a signed contract with TVA, so TVA would need to come up with a backup group that would convert the solution to an oxide.
And also the 35 glass canisters are included in the projection of the current storage capacity being max in 2019.
Yes.
Correct.
Yes, that's part of the waste system plan. That our number.
That's always been part of that.
Yes, the max is a lot more than 35.
Yeah, on that same line, we always see going into H Canyon some of the stuff from, the tank farm, we always see stuff coming from H Canyon in that scheme.
Right.
And if we process more of this plutonium, it generates some waste that has to be vitrified. Is that all part of that?
That's all part of it also, and it's the same thing, and we're actually looking at some waste minimization efforts within the canyon itself. One of them that we're looking at hasn't been fully vetted and went through SRNL, but we're working it, is to literally take what we call the raffinate off the columns that would normally go directly to the waste, and using that acid as the makeup acid for the canyon dissolvers, so that you reduce the amount of acid that you would be needing in the facility. That has not been fully flushed out and worked out, but that's one of the things. We've got several initiatives in H Canyon due to the waste limitations that we're trying to implement in H Canyon that will reduce the amount of waste that we send to the tank farm anyway. Okay, again, we're going to send 40 metric tons of LEU out to Hanford for TVA, to Richland, and again, it'll only generate about 35 glass canisters. One of the things I added, this is the Canadian liquid. This is a material the department is planning to bring to Savannah site from Atomic Energy Canada Limited. It is a resulting solution basically from processing targets that contain highly enriched uranium. It's basically coming from the Moly-99 program, where they produce Moly-99, molybdenum-99. It's for the medical industry. Give people an idea, 95% of the molybdenum, Moly-99 that's produced comes to the United States for medical. So Moly-99 is critical in the medical isotope business. The uranium here, again, came from, is U.S. origin material. And so we're bringing it back in. You'll hear a lot of time it's target material because it was actually, and it's been part of the EIS in the past. The spent fuel EIS is the material that was identified. We're talking about 6,000 gallons of solution, then you get some flush material that comes with it.
Was this part of the Atoms for Peace program?
I'm not sure about that. I don't think it was the Atoms for Peace, but I do think, it was U.S. origin material.
And we had an agreement that post-irradiation would come back.
And we had that in the book. At times Canada was not that excited about sending it back to us. I mean, it wasn't part of what they were planning, but now they have requested that they be able to send this material back to us. Again, we're going to receive the HU solutions directly to H area. We'll unload them, process it through the canyon. It'll be blended with the uranium coming from the spent fuel program that we'll be doing. And then we'll discard the fission products to the liquid waste system, purify the solution, down blend it.
Is Canada paying for this?
Yes, ma'am. One of the things, and I know I heard it at the last CAB meeting in Beaufort, was people are really concerned about the transport of this material over the highways. This solution will be shipped actually in a spent fuel cask. It will not come in just a normal, it is in a spent fuel cask. It's called an International Legal Weight Transport cask. Being a license application has been submitted to the Nuclear Regulatory Commission. Inside the cask, there are 4 small tanks, roughly about 16 gallons each. Originally, we were hoping to have a single tank, but due to the concern that, or the issue that the Nuclear Regulatory Commission had, they made the group design it into 4 small tanks. Once the NRC completes their review, they'll issue a license or certificate of compliance, and then the U.S. Department of Transportation will validate that also. It is planned that the International Atomic Energy Agency will apply seals to the containers in Canada, and the seals will either be returned to AECL, or Atomic Energy in Canada Limited, or to the Atomic Energy Agency. That hasn't been decided who gets the seal. But what that tells us is whatever leaves up there is what we get when it comes to Savannah River. There's nobody tampered with it in between. Let me give you.
Is there a timeline on this?
Excuse me. Do what now? I'm sorry.
Is there a timeline for that?
We are hoping to begin shipping in 16, and it'll take roughly probably a year to 18 months to complete the program. And some of that depends on weather conditions of transporting it from, Canada down to Savannah River and things of this nature. Now, I was going to show you 2. People have concerns about the cask and some of the things. Go ahead and click this. You can't do them. Oh. Anyway, I apologize. These are the video clips that, if you've seen in the past, where a spent fuel cask was set across a train track, and a locomotive doing 60 miles an hour hit the cask. It went flying everywhere, but once it ended up, finally, they tested it, there was no leak at all in there. The second one was also with a 18-wheel truck going into a concrete wall. Again, at about 55 miles an hour, it again shows the cask withstood that impact. That is the type of testing that goes into these casks. So when people are talking about it's going to roll over, it's going to leak, it's going to do this, those containers, those casks go through significant testing, and the chance of an accident leaking is very, very minimal. And I was just going to have those as video clips, hoping that we could, show you.
I'll check on that and we'll see if we can't get them out cab numbers.
All right.
Alan, what about the over-the-road record? I'm assuming they haven't had any issues.
Yeah, again, that's why they did that test with a tractor trailer going into a wall at 55 miles an hour. Was like if, I'll say the truck is riding down the road and somebody runs a stop sign and comes dead into the side of it. That's why those tests were performed on these casks, to show that they will withstand. Again, these are the casks that normally ship spent fuel around the world.
I think she was at the record of the transportation.
Oh, is that what you were asking, Rose? Oh, I'm sorry. I apologize. I thought you said wreck.
Right, yeah.
Excuse me. The record is a very, it's a high safety record. There's been very few incidents of any wrecks involving the spent fuel cask. I don't have the statistics with me.
But yet there had been some concern, because they had to go from 64 gallons to 4.
Well, we were
16, right?
We were originally going to have a single tank, probably with about 70 gallons in it. The NRC, due to freezing, that's what they're more concerned with. Is during a freezing, you freeze a solution, your uranium concentrates in the bottom, you can get a criticality. So that was the reason that it was taken from one single tank to 4 small tanks in there, was from a nuclear safety criticality, not from a safety of an accident.
Not from an accident spill. Okay.
Has there been a criticality?
Ma'am?
Did they ever have a criticality?
But the theoretical is, if you send material like through Canada, it gets in a snowstorm and it's stranded there for, a week, and the temperature is minus 40 degrees, what would happen? What's the theoretical? You go through those theoretical accidents, and they came up and said, hey, if you have it in a big cask, you may have enough material if it all went to one little spot. Again, it's perfect thing, everything goes in one spot, it freezes, you could get there. In 4 smaller tanks, you can't even get there, so that was the rationale behind there going to 4 small tanks. That is a significant impact to us from being able to just unload a tank, single tank, and now we've got to handle 4 tanks, but we're doing that in the part of the facility line. Again, as a summary, H Canyon Complex remains a unique national asset for large-scale nuclear material processing, the only one left in the United States. We did complete the SRE dissolution campaign this year. We've initiated HEU aluminum class spent fuel processing, and we'll continue. We completed the prep and actually started up producing plutonium oxide, and this year completed the ventilation system improvements. We've maintained our operator and equipment proficiency, and we're doing the prep to receive the Canadian HEU liquids from the Canadians. Overview look at. Thank you. Is there any questions?
What has all this meant in terms of employment?
Means we get to retain people working in H Canyon for, like I said, the process.
Well, how many people is that, Alan?
Directly in H Canyon is about 700 site supporting people is about 1,100 people supporting H area.
Great, thanks.
That's 1,100 in addition, or up to 1,100?
Well, what you have is you have direct people in the facilities that are directly related. Then you have people outside the facility procurement, different, people that support organizations, and that's what makes up the additional up to 1,100.
But no ads. We're not going to add.
Part of these programs, like I said, HB Line is getting up to production of a metric ton. They're adding some operators. Mm-hmm. The Canyon is also adding some, to support the Canadian unloading as far as, employment. So we're adding, but it's not large scale. I mean, we're not adding 300 or 400 people. It's 20, people to staff shifts and things of that nature.
So it's internal people you're moving over?
No, we've been out hiring, externally hiring operators. SRS has went out and done a lot of interviews. I've been hiring some of the people, hiring engineers. I think, if I'm not mistaken, this year they've hired over 200 additional engineers, although they're losing engineers that are retiring or moving to other places. Some of us, like myself, are getting old and closer to the retirement age.
Hey, Alan, how much liquid waste is going to be produced from the Canadian waste, and was that already figured into this latest system plan?
Yes, it's in the waste system plan. Exactly, I don't know, because it all combines with the uranium going through from the spent fuel, so really it's very little, I want to say less than a canister of waste when you factor it all in. Because there are some fission products in there, so I can't say there's none, but it was less than a canister.
So that's a canister of vitrified waste.
Yes, less than a canister of vitrified waste, and it is in their system plan.
Okay, but how much liquid waste do they have to process to get that one canister? That's my question.
Ooh, I could not answer that one. That would be something that the liquid waste, Gene Ridley or Sonny Blanco or Jim Folk would have to answer. I just don't know that information. I'm sorry.
All right, thanks.
Any other questions?
Recently, there was an article in the newspaper about replacing acid recovery unit. Was that in F area or H area?
H. We are in the process of replacing acid recovery units. We have actually completed the installation. We are now into the product checkout, connecting, and doing all that. I want to say it's in the late spring of next year when it'll actually return. We've got to get the acid recovery unit up to process fuel to recover the acid.
Because I thought it said it was an F area, and I didn't understand. That didn't make any sense at all.
No, it's the H area.
But this would, yeah, right there. Yeah.
All right, anything else?
Anybody?
Trying to get y'all video.
Oh, yay. We're running out of time here because we still have to discuss 2 draft recommendations. So thank you very much. Very informative. on the agenda is a discussion of two draft recommendations, which I've sent out 2 or 3 times to the committee for review and requested comments. Are there any comments at this time?
Which one are you talking about?
Let's start with the L Basin CAB Oct, potential impact of deep geologic storage. Basically, what this recommendation says is that we have had an incident of organic materials occurring in the L Basin, and there have been other incidents throughout the nuclear area in the high-level waste tanks, as well as in the spent fuel that was taken from 3 Mile Island and a few other areas. And although this is a very iffy area, the recommendation addresses the concern that since this was a very unpredicted incident, if it were to be transferred to a deep geologic repository, which the earth scientists have concerns over because they consider those repositories as open systems of matter and energy, which are unpredictable and uncontrollable, the possibility that something unforetold could happen with such organic materials exists, and therefore some kind of detection system should be developed so that if that should occur, the people who maintain and monitor this deep geologic repository, which the government plans to build in the future, would have the option of addressing this problem. And of course, the ways in which it would be addressed should be part of the study that we're recommending.
Rose, I have a comment.
Yes, please.
I thought that the background was way too extensive. Okay? You know, it just kept going, just chipping your teeth, and nothing was getting done. And then when I got from there to the discussion, I had marked the paragraph, the last paragraph in the discussion, and it seemed to me that this was not substantial, and you know, it is the meat of the thing. It looked like to me, and you ought to get the English right so that it shows that.
Okay, you want some rewording in the last paragraph of the discussion?
Yeah, and then recommendation 5, I would argue that's go hire some more SRNL people, and that's not the purview of CAB.
I think the recommendations work really well based on the discussion. The only part that I had a question on for number 3 was if you can put in request and provide.
For recommendation
3? For recommendation number 3, so we would read DOE request and provide full funding.
Leah, I'll take a look at the background and see if I can reduce the language.
Okay, I think that it's just too much, huh?
Do you have any specific recommendations?
No, I did not read it with that in mind. I was just reading it to get through it before I came to the meeting because I knew you were going to want to talk about it.
Okay, I'll take a look at it and see if I can reduce the language.
But number 5 really bothered me more than anything else. It looks like you're saying, hey, you know, we're going to take care of SRNL. And that seems to be out of the purview of the CAB.
Well, I think the CAB's position, at least over this last year, has been to strongly support SRNL.
Well, write it to do that, but don't. I'll just tell you the impression that I got when I read it.
Okay.
I said, oh my God, what's the CAB doing on that?
I'll
You know, maybe with, Jenny Jones CAB, maybe we could, it seems like we've done 5 in a separate recommendation, and the recommendation does really well with 1, 2, 3, and 4.
I would think you could do that, yeah.
In recommendation 2, that's National Lab. I think we may have already put 5 in a different recommendation.
So you're saying trying to combine 2 and 5?
I'm saying 1, 2, 3, and 4 could stand alone.
We did put a recommendation out on the lab, but it didn't have anything to do with reducing actually that's sort of like partitioning or transmutation.
Right.
And we didn't actually suggest that the labs do that.
Well, what I was thinking is 1, 2, 3, and 4 seem to relate directly to this one with the cobwebs.
Yeah.
And that 5 maybe could separate it and gone into maybe a little bit more specific. I think we've done 5, but I'm not sure. I have to look it up.
Can you give me something in writing? Can you gem up something for me?
Well, my concern with it is again, it's about geologic storage. Now, this was sent. I mean, all of our recommendations are sent to DOE staff.
That's
okay?
what we were told tonight, that they will go over to the NE.
But so I mean, so it'll be rejected probably.
It'll be, well,
I mean,
it'll be
they
transferred to NE. If I understood correctly what was said tonight, our recommendations that do address geologic repository issues, or not geologic repository issues, but the federal repository will be transmitted to NE.
They're copied on all of the response letters and then get the actual recommendation.
Does that address your concern?
Well, yeah, I mean, well, I mean, it'd be nice if that is stayed, like you said, I mean, we're hearing that now, but.
Yeah. Yeah, we really, there was a point of confusion on that. We really need something in writing, because we've had one letter back from Dr. Moody indicating that one specific recommendation was transmitted or would be transmitted. The others would simply contain language to the effect that it involved the federal repository and that was outside the purview of the CAB.
Okay.
So if it's a general policy that they go over, we need to have something in writing.
That's clear, understand.
Thank you.
Alrighty, then I'm fine.
Okay.
I mean, I don't want it to be just a wasted effort.
Yeah.
You know what I mean?
I understand. I
Okay.
understand.
Because if that's the case, then you know, it's not worth it. Okay.
All right. Comments? I will look at some of the language, send it back to committee, and assume then that we're going to put it forward in the next full board meeting for consideration or approval. The next recommendation is something that I brought up in discussion at our last meeting. That is the difference between spent nuclear fuel and used nuclear fuel in terms of official policy. This CAB has been told in at one venue that the new official terminology was spent nuclear fuel. We have also then been told that the official terminology is used nuclear fuel. They imply two different functions. Spent nuclear fuel implies that it is ready for disposition in the sense of the Oak Ridge National Lab study and report of 2012, which said that such material has no economic or national security value and therefore can be thrown down the rabbit hole with no possibilities of retrieval. Used nuclear fuel, on the other hand, was a term that was substituted by Secretary of Energy Stephen Chu when he indicated that it still had some good stuff in there and that it could be reused, which implies, of course, ultimately that 800-pound gorilla in the corner reprocessing. So we would like to have a specific decision on what the official term is and what the definition and intention of that usage is. Do we have any comments on this recommendation?
I have a comment on this recommendation.
Of course you do.
Of course I do. I read it. You know, you sent it to me to read comments.
Yes, I did.
I enjoyed the history lesson. Thank you.
Yeah.
For telling me when all these things occurred, but collapse the background.
Okay.
Again, you know, that's your point is pretty clear, and you ought to state that. You know, don't beat around the bush here. I never heard the term used nuclear fuel, or whatever it was, spent nuclear fuel or something, and I never heard that other word. But okay, you know, and I didn't have as much trouble with the recommendations on this one as I did on the others. I wondered on recommendation 4, the purpose of, I mean, I'm all for it, but that just seemed like a strange thing for the CAB to be asking DOE to do.
Well, I guess
I think of the CAB, you guys ought to be doing it yourself, directly. You know, public consumption, you know, taking care of the public. You are the go-between,
yeah,
or the closest. But this one didn't give me as much trouble, except I read it and I said, oh hum, I've just read history. I had read my 60th year history.
Okay.
I didn't think it was necessary, and certainly from what I'm hearing you say now, it's not necessary.
I will take a look at the language and see if I can find places to reduce it.
All right, I had a question about number 1, the recommendation number 1. First of all, get rid of the word DOE there because that's just a repeat. But at any rate, so this is asking. I mean, it sounds like to me this is the big deal. Because we want them to determine of the post irradiated fuel which ones we're going to process and which ones we're not. I mean, which classifying these, or are we wanting them to do an inventory? I'm not quite sure.
No, I want them to define the terms. What language are we going to use? We've been told.
Okay, but for both defense and commercial.
Yeah, post-irradiated fuel. What I'm trying to say here is that they have used 2 terms, and they have said they're mutually exclusive.
So what would this be, though?
Hello, can you hear me? This is
to which?
Can you hear me on the phone?
These fuels are going to be utilized.
There's somebody on the phone talking to you.
Yes, go ahead, please.
Can you hear me?
Yes, please.
Yes, this is Tom Clements, and I'm sorry, I'm calling by Skype from Scotland. And I'm going to be visiting near the Sellafield site here in a few days. But I've said this before at meetings, and I've interacted with DOE about this, but the Nuclear Waste Policy Act of 1982 defines spent nuclear fuel, and it's the only legal definition, and it says the term spent nuclear fuel means fuel that has been withdrawn from a nuclear reactor following irradiation, the constituent elements of which have not been separated by reprocessing. That's the legal term. The term used nuclear fuel is what I call an extra legal term, but if you're asking DOE to explain what the definition is, the law is quite clear on this, and the Nuclear Regulatory Commission uses the correct terminology, but DOE has wavered and is not using the official legal terminology. So I just wanted to add that for the discussion.
Thank you, Tom. I will refer to that in the rewrite.
Okay, thanks. You can find it right in the Nuclear Waste Policy Act if you search for SPINT.
I've got the Policy Act. I will. Thank you.
I almost am sure that there's, DOE has one out there of their own that lists what the definitions are.
Yeah.
Is that not correct?
We have a new book of terminology, but I think Tom Clement's point is that the 1982 Nuclear Waste Policy Act is a congressional act, and the language in that act probably overrides any other rewrite of language.
That's correct.
Lee, you are correct. The department has an order on defining what spent nuclear fuel is and what true waste is. It's all in for DOE Order 435.1, and I don't have the exact excerpt, but we can get that for you.
Now, now if DOE, if the CAB takes exception to that, they ought to tell them that. But this is just kind of a mush. This recommendation is mush. and if you can get this thing and see what that we are, that it is, they use the term, what is it,
Use nuclear fuel. That was Secretary of Energy's designation for it. He directed that the acronym SNF be dropped, and that in its place we use nuclear fuel because, according to the Secretary, SNF implied there was nothing left, and use nuclear fuel implies that there's still some good stuff there, and it can somehow or other be recycled, or reprocessed.
How often do we hear all of our elected officials use bad terminology on the TV? I hear it every day. Every day I listen to them.
Well, but Lee, our dilemma here is but we have specifically been told by personnel, DOE personnel on site at SRS on 2 different occasions that these terms were to be used, and they're mutually exclusive. So we're asking, which one are we using? What do you mean by it? Okay. What's going to happen to the fuel? What do you intend to happen to the fuel using this terminology?
We nor DOE are using the term used nuclear.
Well, no, that's not what we were told.
We have used nuclear fuel.
When?
Under the Secretary Chu's administration.
Oh, well, yeah.
I mean, Maxwell DOE, first and foremost, you can write any recommendation you want. Okay, so you're free to do that. Tom Clements is right. The Policy Act does define spent fuel, and for decades, commercial reactors as well as DOE use spent nuclear fuel. Under Deputy Secretary Poneman, when he came into office, just as Rosa said, wanted to convey that the fuel that we have, the spent nuclear fuel, whether it be commercial reactors or the research reactor fuel that we have, and so he just thought that used nuclear fuel conveyed the inherent value in the fuel as compared to the term spent nuclear fuel. So he, under his administration, decided to coin a new term. Understand it could lead to confusion, okay? Again, the fuel that we have was removed from in El Basin, was removed from a reactor, and whether you call it spent nuclear fuel or used nuclear fuel, the fuel in and of itself, it doesn't care, right? It's there regardless. And our plans that Alan talked about and Maxine talked about, what we're doing with that material is going to be the same regardless of whether we call it spent fuel or used fuel. I agree, a common set of terminology will focus us on a meaning that we can all agree to, okay? But again, it's a history lesson. When Deputy Secretary Poneman came in, he wanted to convey the inherent energy value that's still left within that material. And right now, our plans are, it's aluminum-based fuel. We plan to process that and recover the uranium. There is some, and I guess you could call the SRE material that Alan just talked about spent nuclear fuel. You could, okay? Again, it's going to be, and I don't think the intent is to go by fuel assembly by assembly to say, hey, this is spent, this is used. That would be, you know, futile in the effort to go through all 19,000 assemblies and say, yeah. And so I think our convention is, and if you write the recommendation, we'll probably say, because Deputy Secretary Poneman has moved on, and therefore we can probably go back to the spent nuclear fuel policy. So again, it's more of a convention in terminology, and the material itself, we're moving forward to disposition as quickly as we can, as Alan and Maxine have told you. The 15 budget, it's spent fuel, and so we're probably going to go back to that terminology. So again, history lesson, but feel free to write whatever you want. But I think we're going to go back to this.
Yeah, I think we will, Pat, because I hear what you're saying, but you're saying it, and we need some kind of definition that stands. It needs to be written. Yeah.
Understand.
And Rose, let me add, the EPA also uses the legal term. So the DOE has caused a lot of confusion with this because NRC and EPA use the legally defined term. So DOE is really has muddied the waters with their use of this different term.
And Tom, this is Pat. I would agree with you. And you know, but we also report in through a chain of command, and we follow a chain of command. But I understand you're exactly right. We ought to be consistent.
And Rich Olson put together a booklet on a definition, and in that definition book, it has both used and spent nuclear fuel together as the same. Yes.
Yeah. I understand that, and I have a copy of the book. But the problem, Maxine, is that in the room where we met with DOE people during the tour of the tank farms a couple, 3 weeks ago, we were told that we were going back to the term spent nuclear fuel. Following that, I guess at the last full board meeting, we were told, no, the official term to be used is used nuclear fuel. We have, and these things in my mind are somewhat mutually exclusive. And so, having been specifically informed by DOE personnel, we need a definition that we can use, that we can be comfortable with, that we understand.
In this definition here, it says spent nuclear fuel, and it says C, used nuclear fuel. Under used nuclear fuel, it really defines what was legally spent. Yes. So it seems backwards to me. I mean, if you were going to use the legal definition, these would be reversed. For used, you would say C, spent, rather than, see what I mean? I would do.
I see what you're saying.
Yeah, to me that would have been, this is backwards in terms of if we look at the legal definition. So.
This is Jenny Jones, CAB. How about if we use what you have in your discussion? Because obviously this is something that needs to be clarified, seeing as we've got all these experts on the room. And just say, we want a clarification on the current definitions of spent nuclear fuel and used nuclear fuel.
I agree with you, but I also would like to take Tom Clements' recommendation and refer them to the official definition that's contained in the 1982 Nuclear Waste Policy Act.
I'm trying to think of how to write that in there.
Yeah.
I think we can probably put that in a spreadsheet. I need more time to work on it, though.
My only other question was the difference between 1 and 2. One is a plan that actually, number one is determining the use or lack of use to which both defense and commercial post-irradiated fuel is to be utilized. Not sure what that's asking.
Well, do you think we should just strike that?
Well, I don't know. If you want it to be, I'm not sure what it means. I understand two, but number one is confusing. Determining the use or lack.
Well, I think it should be struck, because we're actually, the point of this recommendation is to address the definition.
Yes, rather than.
Yeah, so let's strike one if nobody has a problem with that.
And this is Pat McGuire. Again, us environmental management, we're not responsible for commercial reactors at all. I would go back to what Jenny said.
Yeah.
Run maybe one recommendation, clarify the terms, spent and used nuclear fuel, period, end of story, if that's what you want. It seems, I don't understand a lot of these other things. If that's really what you want, just say clarify.
But some of the materials that we're getting that EM is doing are from what would be commercial reactors, because if it's been used to produce electricity, isn't that commercial?
Oh, we're getting research reactors.
Yeah.
That's all we get is research.
Yeah, but they had commercial uses.
The German stuff did.
Well, but I mean,
we don't have German material.
But I mean, if one of we just saw one of the recent things talks about this research. It's in Al Basin, I guess. I don't know where it came from, but it produced electricity, and that was purchased. So to me, that's commercial. So I mean, I know you've always said this, but yet we get stuff that's processed that a normal person would say that had a commercial use. It wasn't, looking to see if we can use this material for a medical reason. I mean, they used it to see this electricity, but they also charged for it. I mean, there were ratepayers. Isn't that true in that one?
For the SRE fuel, I think is what you're referring to. There were some commercial fuel in the beginning of the program, way back in the 60s, that they took into Al Basin, but the current program, we only take research reactor fuel.
The research reactor fuel was developed for the specific purpose of civilian use. They did research to produce energy.
I mean, I understand. Yes, it was research, but the outcome was electricity that people bought.
But I'll just, I understand what you're saying.
Yeah.
Okay. That in and of itself, which I find hard to believe either, if someone's paying for something, that in itself doesn't mean it's commercial. It could be a prototype reactor to see, does the government or utility want to continue to invest in that type of reactor? And it may have proven not to be viable for long-term commercial use, and it could be deemed a research reactor. So there's a lot of different points of view on that. So I'm not saying which is right, and I'm not saying which is wrong, but there are what may appear to be somebody's paying for it as a commercial entity. That some people say, no, that's not in and of itself why it would be deemed commercial or not. So if you... I
mean, I understand that we are not getting commercial, we are not getting used spent nuclear
fuel from a commercial utility.
We're not getting nuclear fuel from power plants.
Right.
Okay, I understand that. We say we're not getting commercial, but there have been some that...
Okay.
So in here, we should take out commercial.
It's up.
Well, if it's...
Well, I think you ought to think pretty carefully about what you're trying to do, and if you're only trying to get them to tell you what used and spent nuclear fuel is, that's the...
Can we maybe look at one that just says craft a definition of spent nuclear fuel and used nuclear fuel and indicate the context and usage of when each definition should be utilized?
Yes, and do you want to modify?
Yes, I will. I will do that.
Tina is now manager of this recommendation, and I'm happy to hand it off to her. And Jenny, would you like to take on the cobweb recommendation? Thank you. Okay, we will revise these, incorporating the recommendations from the public and the committee, and I'll send them out ASAP so that we can approve them through email and then present them to the full board for approval and forwarding to the DOE. And spend or use.
I think we are.
Okay.
That's what we are.
All right, moving on. Do we have any other comments or helpful suggestions or? We now move to the public comment period. Do we have further comments from members of our public? No?
This is Tom Clements. Can you hear me?
Yes, we can.
Yeah, I'm Tom Clements with Savannah Riverside Watch, and just a few brief comments. First, I've said it many times, and we didn't hear it again today, concerning the Canadian material. This material in liquid form in the tank at the Chalk River site can be denatured in place to be rendered not highly enriched uranium. And it's a proliferation concern that option has not been considered. No environmental impact statement has been done to consider that option. So it remains a proliferation concern that Canada would not denature in place that material rather than shipping it to the Savannah River site. I've said it many times, I'll just leave it at that. It was good to hear that there's going to be a presentation on the German spent fuel, the graphite fuel, mostly being considered from the Jülich site, but also the Ahaus site. But that's really on the back burner. Some of you know I was just spent a pretty intense 6 days in Germany, and I did go into the spent fuel storage facility at Jülich and interacted with the officials there. So I'll have more to say about that when and also met with a number of Bundestag members in Berlin and went to various other German cities and was also outside the facility at Ahaus where the THTR material is stored. But I will have more to say about that at the CAB meeting in November. And also I've received some more Freedom of Information Act documents, and it's quite clear, and I know the CAB is concerned about this, that there were negotiations and agreements with the Germans 2 years ago on this matter. And DOE was very, very, very tardy in presenting it to the public and to the CAB, which is most unfortunate. I don't think there was openness on this, and it appears to me they wanted to have the whole issue basically decided on before it was publicly discussed. It's not a good situation, but I'll have more to say about that as well. And I am going to meet with an official near Sellafield in a couple of days on plutonium immobilization over here and plutonium disposition, and get a look around the Sellafield area. But there's a rumor that has surfaced again, and the CAB should just keep this in mind, about bringing UK plutonium to Savannah Riverside if the British help pay for the MOX plant. As some of you know, the British have over 100 metric tons of plutonium stockpiled at Sellafield. They don't know what to do with it. They don't have any reactors to use it, and the GE Prism reactor is really going nowhere. So I just would encourage you to keep your ears open if you hear anything about the rumor about bringing UK plutonium to Savannah Riverside, which I think is rather absurd and far-fetched, but it is surfacing again, primarily in Washington, but I'll be asking about that as I interact with people over here. And I'll leave my comment at that, but as I mentioned earlier, I am calling on Skype, so I hope the quality is okay, and I'm currently in Scotland right now, but going to the UK, or going to England tomorrow. So I'll leave it at that. Thank you very much.
Thank you, Tom. Okay, any further comments? Then I think this committee can adjourn. Thank you all for coming.